Hi people and welcome to this video. In this video, we'll be working on the Mathematics Paper 2 Preparatory exam for 2022. And this is specifically from the Gauteng province. Remember that the marks allocated is 150 marks and this paper is for 3 hours. Okay, so we have an information sheet. Remember to round off to 2 decimal places unless stated otherwise. The diagrams are not necessarily drawn to scale. And there is a formula sheet at the end of the question paper. Okay, with that being said, let's get into this video. Question 1 says Mrs. Molefe decided to research the effectiveness of her online classes. She divided the grade 12 pupils fairly into grade 12A and grade 12B. Grade 12A attended face-to-face classes and grade 12B attended online classes. Both classes were taught by Mrs. Molefe for the same duration. The table below shows the time spent teaching in hours and the average results achieved by the learners in their weekly tests as percentages. Okay, so 1.1 says, determine the equation of the least squares regression line of grade 12A. So looking at grade 12A, we're looking at their results compared to the time. Okay, so the hours spent teaching. So to find the equation of the least squares regression line, this is the equation. Y is equal to, and we say A plus BX. So we need to find the value of A and B. And we can find that on our calculator by putting these values in. So on your calculator, go to mode, and then you're going to go for the option stat. Now we are working with a bivariate data set, so we have two variables. Okay, that is our x variables is the time, and then the results, that's the y, because that would be the dependent variable, the variable we're more focused on. We're really just trying to see how effective this is. Okay, so we're going to go for A plus BX, and I need to remove this data first. Okay, and then in place of X, put down your X values, and in place of Y, your Y values. And then you're going to press AC, Shift, and 1, and you're going to get 6 options, but we're looking for information regarding the regression. So go for option 5, which says REG for regression. And then you're going to see your variables. So let's see the value of A first. When we press A, we get 38 points, and we can just round off to 2 decimal places. So that is 38.26. And then B is equal to, and we're just going to say shift 1 on the calculator. And again, go for option 5 for regression. And then B is 2.46, rounded off to 2 decimal places. So this means that the equation of our least squares regression line is simply y equals 38.26 plus 2.46x. And that is our answer. Moving on to the next question. Then question 1.2 says, write down the correlation coefficient of the grade 12A results in respect of the time spent teaching. Okay, so we just need that correlation coefficient. We already have the data recorded in terms of X and Y. Okay, the time is the X values. So you're going to press shift 1 and again go for regression, option 5. And then there's the correlation coefficient. So you can see the correlation coefficient of grade 12A R is equal to 0 points, and that's going to round up to a 7. So 0.97. Okay, and that is our answer. They didn't ask to comment on it yet, so let's keep moving. And now they say comment on the correlation between the time spent teaching and the average results of grade 12A. So you see, to comment on the relationship between the time spent teaching the X and the Y values, you look at the correlation coefficient. It's 0.97. So we can see that it's positive, and it's also a very strong correlation or relationship. So the answer is just, it's a very strong positive correlation. Okay, and that is our answer. So whatever predictions we make using this equation of the least squares regression, or if we were to plot it down on a scatter plot and draw that least squares regression line. Depending on what that looks like, or even looking at this, those predictions are more likely to be very accurate, okay? So this is not necessarily giving information about whether, the face-to-face class is actually working or not. That doesn't really give you that kind of information. It's just telling you the strength of these two variables, okay, or these two data sets together. Okay, so that is it for that question. Moving on to the next question. Question 1.4 says, the equation of the least squares regression line of grade 12B is this. Okay, so this is the equation of the least squares regression line of grade 12B. We don't have to find it, they found it for us. Calculate the difference in the results achieved by each class had Mrs. Molefe spent the average time to complete a particular section. Okay, just words. We just have to unpack this. So they're only asking for the difference in results achieved. Okay, so the difference in, you see how we had the grade 12B and grade 12A results. They want the difference in that achieved by each class if Mrs. Molefe spent the average time to complete a particular section. So she's spending the average time. If you look at the time that we have, right, we have 2 hours, 8 hours, 4 hours, 6 hours, and so on. They're saying if she spends the average time. So we need to find the average of the time. And then we're going to find out how much would they have gotten using the least squares regression line if that was the time spent. If whatever the average of that time is, we're going to take that x value, substitute it into the equation of the least squares regression to get the results of grade 12B, and do the same for grade 12A. And then we'll take those results and check what the difference is. Okay, so let's find that average time first. Okay, so the average time, that is really just the average of the x values. And we already have that. We have that on our calculator. It's recorded there. So it's going to look like this. It's the average of the x values. Remember that in the least squares regression line, okay, on the calculator, it's recording x and y values. So on your calculator, just press Shift and 1. And then you're going to see your options. This time we're not going to go for regression because it's not going to tell us the mean values, okay? But we're going to go for the option that says VAR. So that is option number 4. And when you go to variable, then you start seeing information about the mean of your values. And we specifically want the average time, okay? So that is the mean of the x values. And there we go. That's what it's going to look like. The mean of our x values is exactly 53/7. I like to not round off, so I'm going to take it like that as 53/7. I'll only round off at the end. And what we're going to do now is, if she had taught them for the average time, we're going to find the difference between grade 12B's results and grade 12A's results. So for each grade, so grade 12A, we're going to take the least squares regression line and substitute this as the x value, okay, and see the results that it brings about. That would be the result had she spent the average time teaching them. Okay, so this is the equation that we're going to take, and in place of x, we substitute 53/7. Let's see the result here. Okay, so 53/7, I'm not rounding off yet. And let's see what the results are. You can still do normal calculations here, it'll be fine, and your data is still going to be recorded. Okay, and now at this point, it's fine to round off because we're just going to subtract those values to find the difference. So here, I'll leave this as 56 point, and then that rounds up to 9, so 0.89. So this is the result grade 12A would have gotten if she taught them for this time, this average time that we found. So percent, that is the answer there. And then we're going to do the same thing for grade 12B. So this is grade 12B's results, and let's substitute 53/7. Okay, and this is what we get as the y value, and it is 50.89. 0.11%. Okay. And now we're going to subtract. So the difference they're referring to, the difference in result, this is what it's going to be. So difference, we can see that grade 12A is higher. So we'll just say 56.89% minus 50.11%. And this is equal to, that's just going to be 6 points, and then that is going to be 7 and 8. Okay, and that is our answer. It's going to be 6.78%. Okay, that is, of course, if we don't round off at this point. If you like and you wanted it to be more accurate, you could have just taken this entire, calculation minus that one to see what you get. Okay, so like that. I see that the rounding actually affected it. So let's just say we didn't round off, okay? So you would have to leave that as, the 8, and then it kept going. So let's just leave it like this. That's going to be 6.77%. And that would be the exact answer if we didn't round off and only rounded off at the end. Okay, so that is it for question 1.4. Moving on to the next question. Question 1.5 says, identify an outlier in grade 12B. Okay, so where's the outlier? You can see that in grade 12B, you see how these marks are 63, 45, 47. Okay, they're really not that far apart. And then we see 9%. So that is the outlier. Okay, so that one is far from the trend and far from the rest of your values. So our outlier is 9. But we can't just say 9. We have to say the full thing. So the x value is 2 and the y value is 9. Okay, so as a coordinate, it is 2 and 9. And that is our answer. Moving on to the next question. Okay, question 1.6 says, indicate a valid reason for this outlier. A valid reason. Well, just indicate any valid reason. So these were the results. Okay, grade 12B was taught online. What could be a valid reason why they would perform so poorly if they were taught online? And you can just give that reason. Okay, so any valid reason. I don't know. It was their first Zoom meeting. Maybe nobody charged the devices. I don't know. You could just give any valid reason for this. It's more based on opinion, okay? And as long as it's logical and it's reasonable, they will accept it. Okay, lol, I'm just going to go for this. The reason why I'm just going to go for this is because, if we look at the other marks, they started doing well. They went for 8 hours. They were taught for 8 hours and they were doing better than they did here. So I'm just going to go with lack of preparation. Okay, and that is it for question 1. Question 2 says, Formula 1, aka F1, race car drivers have to endure high G-forces at extremely high temperatures. They tend to lose close to 4 kg of weight after every race. Okay. Question 2.1 says, the table below shows the total weight lost by 40 different race car drivers after the duration of one race. Okay, so this is the interval of weight lost in grams and then the number of drivers that fall into that particular category. So 2.1.1 says, write down the modal class of the data. So the modal class means the class that appears the most. So if a class appears a specific amount of times, it will show in the number of drivers that were in this class. So the modal class would be the class that has the highest number of drivers, which we can see is 15. So that is where their weight was greater than or equal to 2,500 but less than 3,000. And that is our answer. Moving on to the next question. Question 2.1.2 says, calculate the estimated mean weight loss of the race car drivers. Okay, so the estimated mean, it can take quite a while. So let's just first get our table down here and then we'll find the columns that we need to find. Okay, so this is our columns and here's what we need to find. We're trying to find the estimated mean. It's still the mean at the end of the day. So you still need to take all the values, add them together, and then divide by the total number of people or drivers that we have here. We can see that the total drivers are 40, but now our data points, we need to find what those are. It's the estimated mean. So we're going to find this not by taking these individual values. We can't really do that. And that's why we're going to have to estimate. So here's what we need to do. We need to find the midpoint of these weights. Okay, so in each category, we know, for example, there's one driver that lost within 0 to 50 grams, right? That's the weight that was lost. Okay, but instead of saying from 0 to 500, we're just going to take any number there. We're going to just take the midpoint of this, the middle, like taking the average. So we'll take 0 plus 500 divided by 2. Okay, so that's 500 divided by 2, which is 250. So this driver, we're going to classify the weight that he lost as he lost 250 grams. Okay, so that's where the estimation part comes from. So it's the estimated mean. Okay, because we don't actually have these data points. We can't actually physically see in each category how much each driver lost. Okay, and then we'll just do this for the rest. So 500 plus 1,000 is 1,500 divided by 2. That's 750 grams lost there. And this is 2,500 divided by 2, which is 1,250. And then 1,500, that's going to be, when we add them together, 3,500. And then that's going to be 1,750. And then 4,500 divided by 2, that's going to be 2,250. And then 5,500 divided by 2, that's already 2,500 and then 250. So 2,750. Okay, from these you can see that we just keep adding 500. Okay, so the next one will just be, that's 500. And so that is 3,250. And now that we have these midpoints, remember that there are specific amount of drivers in each category. So here, there's only one driver who lost, was saying an average of 250 grams. So here, we're going to actually just take the midpoint and we'll multiply it by the number of drivers, the frequency. And that will give us the total weight lost in each category. Because it's not just one person in each category. Okay, in this case, yes, we have one person here. So the total weight lost here would be 250 grams. But here, when we get an average of 750 in this category, you see that there were two drivers here. So it would be 750 times 2, which is now 1,500. And then we're doing the same thing to all of these. Okay, and then we multiply like that. So these are the total grams lost in each category, okay, depending on the amount of drivers we have there. Okay, so we have this, and this is each of the grams lost in each category, depending on the amount of drivers we have. So then you can add all of this up. It gives us 90,500. Okay, in total, 90,500 grams lost. And now we need to find that estimated mean. So to find the estimated mean, this is how we'll find it. I'll just say the estimated mean, and for mean, I'll just say mean, is equal to, we'll take the total grams lost divided by the total drivers. Okay, so that's 90,500 divided by 40 drivers, and that would be the estimated mean. Okay, and that is 2,262.5 grams. Okay, as an estimated mean, and that is our answer. Moving on to the next question. Question 2.2 says, the recording of the weight lost in the second race was made a month later. The amount of weight lost in race 2 was k grams more than in race 1. It is given that the maximum value of the ogive representing race 2 was 3,504 and 40. Okay, and then the graph was grounded at 4 and 0. And they want us to sketch the ogive, the cumulative frequency graph, representing race 2 in the answer book. Okay, so do you see that? Here they told us that the amount of weight lost was k grams more than race 1. Okay, so k grams more. So what is that value of k? We can actually find it here. given what they're telling us. They told us that the maximum now happens at this. So the ogive, right, that maximum they're referring to, the ogive ends up looking like an S, right, like that. And if the maximum is at 3,504 and 40, okay, this is still 40, meaning there's still a total of 40 people, okay? But now it's ending at 3,504. So do you see from this that the last weight that we had, okay, was 3,500. If this is 3,504, it means that 4 grams was added extra. Okay, and then we can also see that and confirm this from this part where they tell us that the graph was grounded at 4 and 0. So where it touches the ground or this x-axis is at 4 and 0, 4 and 0 like that. So here, where did it touch the ground before? From the way these classes look, you can see that it had an x value of 0. And this value over here, whatever this is, regardless of whether it's 0 or not, it always goes on the cumulative frequency. It will go with the y value of 0. So it means that this graph would have been at 0 and 0 at this point. And then the highest it would have gone would have been 3,540. But this one is going to 3,504 and 40. And this one is going to 4 and 0. So clearly that k value that they're referring to is actually 4, because our graph should have looked like this, and it actually just shifted to the right because the k grams was added. Okay, so 4 grams was added. Okay, so it just means that across all the grams, when we're drawing this ogive, we're just going to add 4. So let me take this as it is, just so that we know what we're doing and how we're going to sketch this. Okay, so with the ogive, we're going to need the cumulative frequency. Okay, but this is how our ogive is going to look. Instead of starting at 0, we know it's grounded at 4 and 0. So this is not going to be 0 anymore. This x value, everything increases by 4, all the x values. Because we can see 4 is that k value that was added. K is equal to 4. That is the extra weight added. So we'll say this is 4, and then this will end at 504. And then that will be at 504. And this would be at 1004, okay, and so on. So this is what it looks like. And now we can go ahead and find the cumulative frequency column. Okay, so this part is really quick to get. You're just going to take the frequency and you're just going to add as you go on. So we first just drag 1 here, and then 2 plus 1 gives us 3. 3 plus 3 gives us 6. 6 plus 8 gives us 14. 14 plus 6 gives us 20. 20 plus 15 gives us 35, and 35 plus 5 gives us 40. And there we go. This is our cumulative frequency column that we have. And now when drawing the ogive, we're going to take it like this. Remember that whatever number is here, that always goes with the y value of 0. These are your x values. And then from here onwards, you're going to take this as the x value, and then the y value is 1. And then this is your next x value, and the y value is 3. And next one, and the y value is 6, and so on. Okay, so here is what our ogive looks like. Okay, just putting down all these points. And you can just label your x and your y axis. So on the y axis, we have the cumulative frequency of the number of drivers, but you can just say cumulative frequency. And then on the x-axis, we can just say, since it's the interval of the weight lost in grams, just say the weight lost in grams. And I'm just going to title it ogive of race 2, okay, because this is just the second race. So here we go. Okay, so this is what it looks like. And then we just plot in our values. So remember, these are all the x values on the x-axis. And this one always goes with the y value of 0. That's that point that is grounded, okay, on the x-axis. So that's going to be 4 and 0 that we have there, 4 and 0. And then the rest of the points, make sure you take them with these values. So that's 504 and 1, 1004 and 3, 1504 and 6, and so on. Okay, 504 and 1, it's probably somewhere there. 1004 and 3, that will be like in the middle. 1504, and then that one goes with 6. And so it's just higher than 5. And we'll just plot down all our points. Okay, so there we go. This is what it's going to look like. And then you just join your points. Okay, so join all of those. Okay, there. So that is our ogive. And moving on to the next question. Question 2.2.2 says, how will the range of raise 2 compare with the range of raise 1? So the range refers to the y values. So did the y values change? No. If you look at all the y values, they're still the same. Okay. With our ogive, it stays exactly the same. That's not what changed. What changed was our x values. So we will say they will not change. They will remain the same. Okay, so moving on to the next question. Okay, question 2.2.3 says, determine the average weight loss in race 2. Okay, expected, because they asked you for the range. So they just want to see if you know what changed. Okay, so in race 1, you see, we already found the average. The average was this. In race 2, what changed? So you see that in all the weights, 4 grams was added. But it's 4 grams across everything. 4 grams here, 4 grams everywhere. Okay, so if you found the average of what was added, it would be exactly 4 grams. Okay, you can easily compare this by looking at the new one. If you wanted to find the, let's say, the estimated weight loss in this category, okay, like when we were calculating the estimated mean, you would say 4 plus 504 divided by 2. So that will be 508 divided by 2. And so that is 254. Now you see that when we were calculating the estimated mean, the weight loss in this category was 250 grams. You see that that's just an added 4 to it. So we're just going to take the mean that we already had, the average here, and just add that 4 grams, okay, that has been added because it's 4 grams across everything. So the average weight added was 4 grams. So just plus 4 grams. So that is 2,266.5 grams. And that is our answer. And that is it for question 2. Question 3 says, in the diagram A, which is -3 and K, B, 4 and 8, C, 5 and 0, and D, -2 and -4 are vertices of the parallelogram ABCD. Diagonals AC and BD bisect each other at P. The angles of inclination of AD and BD are alpha and beta respectively. AD cuts the x-axis at E. F is a point in the 4th quadrant. And you can see they have not given us any information about its relationship to the rest of these points. And the first question is to determine the gradient of BC. So looking at BC, this is B and C, we can find its gradient. So here's the gradient formula. And we're just going to substitute our points. So I'm just going to say top minus bottom. So the gradient of BC will be found by saying that top value, that y value of 8 minus 0, and then the x value of 4 minus 5. Okay, 8 minus 0 is 8, 4 minus 5 is -1. So therefore, the gradient of BC is equal to -8. And that is our answer. Moving on to the next question. Question 3.2 says, if the distance between points A and B is the square root of 65, calculate the value of K. Okay, so just one variable is missing. So it's the distance they gave us, meaning you're going to use the distance formula, which looks like this. Okay, and the distance of AB is the square root of 65. So in place of the distance, we can say square root 65 is equal to, and then x2 minus x1. You can just focus on one of it being x2 and x1. I'll just focus on this being x2. Okay, so that's -3 minus 4 all squared plus k being the y2. So that's k minus 8 all squared. And we'll say in the square root of this. Now, to solve for k, you see that we just have to get rid of that square root. So we can square both hand sides of this equation. And so, therefore, that becomes 65. And then here, the radical also breaks open. And we have -3 minus 4, which is -7. -7 all squared is 49. And then let's just add here. Okay, so I'm just going to put this in front of it. We have k all squared, which is k squared. And then first term times second term is -8k. Then times 2 is -16k. then last term squared is positive 64. And then that gave us 49. Okay, so it's a trinomial, just transpose the 65. So we'll say that k squared minus 16k, and let's add these two together and then take that over and becomes negative. Okay, so what is 64 plus 49? That is 113. And when we take 65 over, it becomes minus. So that's minus 65, and that's 48. So we have positive 48, and then it's equal to 0. And this is our trinomial. And let's factorize. So, okay, open up two brackets, k multiplied by k. Factors of 48 that give us 16. That can be, okay, 48 divided by 12 is 4. Okay, so because the middle is negative, it means that both factors will be negative, because negative times negative give us a positive, but negative minus value will be negative. It will stay negative. So we have negative 12 and negative 4. So these are the two factors we have. So therefore, k is equal to 12 or k is equal to 4. And now we'll just have to decide based on what this point A looks like. So A is a point in the second quadrant, and we can see that the y value of this point will be positive, yes, but we're going to now have to look at this in relation to the other points that we have over there. We had to choose between 12 and 4. So if this point over here, B, if this has a y value of 8, this is 8, then this can't be 12. Then that means that is 4, okay? Just looking at it in relation to the other points that we have. So therefore, it means that k is actually just equal to 4. And that is our answer. Question 3.3 says, prove using analytical geometry methods that BP is perpendicular to AC. Okay, so using the rules we know in analytical geometry, let's show them that BP is perpendicular to AC. The rule with perpendicular lines in analytical geometry is that if two lines are perpendicular, the gradient of one multiplied by the gradient of the other line give us -1. So that's what we need to show them here. So with BP, you see that this is on this line BD. So we can just point out that the gradient of BP and BD are the same since they are on the same line. They're collinear. And then we would have to actually find the gradient of BP, find the gradient of AC, multiply them, and if they give us -1, they are perpendicular. Okay, so let's go. We can go ahead and tell them gradient of BP and BD are the same thing. So I'll tell them that the gradient of BP is equal to the gradient of BD. So I'm just going to focus on finding that gradient of BD. So let's find the gradient of BD. I'm not going to rewrite the gradient formula because we already, wrote it once. That's fine. Let's just take the points we need. We need B, D, A, and C. So let's just get those points. Okay, and just remember we found K to be 4. So this is 4. So gradient of BD, I'll say top minus bottom. So y2 minus y1, that's 8 minus -4, which becomes +4, over 4 minus -2, which becomes +2. So that's a 12, and that's a 6. 12 divided by 6 is 2. So the gradient of BD is equal to 2. And now just find the gradient of AC. So gradient of AC would be found by saying y2 minus y1, so just say 4 minus 0 over -3 minus 5. And so that is 4 over -8. So the gradient of AC is equal to -1 over 2. Okay, and then just show them. When we take the gradient of BP, because that's the same thing as the gradient of BD, so gradient of BP multiplied by the gradient of AC, let's see what they give us. That is 2 times -1 over 2, which is indeed equal to -1. So therefore, that concludes that BP indeed is perpendicular to AC. And that is our answer. Moving on to the next question. Question 3.4 says, calculate the coordinates of F if ACFD is a parallelogram. Okay, so let's look at that. So we need to find this if this is a parallelogram. So let's connect these. So it's going to go from A to C to F to D. Okay, so there are a number of ways to prove that a shape is a parallelogram. And one of the ways, and it would be an easy way here in this case, one of the ways to prove that a shape is a parallelogram is to show that their diagonals bisect each other. So if you connected AF and DC, that those diagonals bisect each other. And what it means is that they share the same midpoints. The diagonals midpoints are exactly the same. So that's what we're going to do. We'll find that midpoint, okay? So use DC, since we have those 2 points, find the midpoint, and then use that midpoint to find F, which is missing, and we can call it X and Y. Okay, so like this. And let's go ahead and find that midpoint. So we'll find the midpoint using DC. So we're saying we're finding the midpoint of DC. Here is our midpoint formula first. Okay, so now the midpoint of DC will be found by saying 5 plus -2, which just becomes 5 minus 2 over 2, and then 0 plus -4, which is just 0 minus 4 over 2. So this simplifies to the midpoint of DC is simply just equal to, we have 3 over 2 and -2. Okay, so this is what we have as our midpoint. And we're going to use this point, 3 over 2 and -2, to find F. So we know that the midpoint of DC and the midpoint of AF would be exactly the same, since this is a parallelogram. So we're going to use that as the midpoint, and then these as the endpoints of AC. So again, we are using the midpoint formula, just in a way that we already know what the midpoint is. So the midpoint of AF, we'll find this by saying x1 plus x2, but I'll just start with this as x1. Okay, so that's x plus -3 over 2, so it's just x minus 3 over 2, and then y plus 4 over 2. Okay, so this is the calculation for the midpoint of AF, but we already know the midpoint of AF. It is 3 over 2 and -2. So these 2 points are equal. They represent the same thing. This is the calculation. This is the actual midpoint. So we're going to equate their x and y values, meaning this x value of x minus 3 over 2, that is equal to this x value of 3 over 2. And this y value of y plus 4 over 2 is equal to this y value of -2. Okay, to solve for x, you can see that the denominators are the same and just equate the numerators, or you could just see this as multiplying both hand sides of this equation by 2. So that denominator cancels. Therefore, we have x minus 3 equals 3. And if you transpose this, it becomes plus 3. So that is x is equal to 6. Okay, on this side, we can also just multiply the denominators by 2. So times 2 times 2. And so this is y plus 4 equals -4. Transpose that 4, it becomes negative. So y is equal to -8. And there we go. It means that this point F is 6 and -8. And that is our answer. Moving on to the next question. Question 3.5 says, calculate the size of angle EDO correct to 1 decimal place. So EDO, let's just see what it looks like. And let's see how we can find this. Is this angle EDO? Okay. It's really the angle ADO or ADP. So you see that we can actually use this parallelogram we already drew to find it. Here's how we can find this angle. We can draw a line parallel to the x-axis at the point where angle EDO is created, which is at this point over here. So we can better understand how to find this angle. And then if we find the angle of inclination of line ED, okay, which is really the angle of inclination of line AD, so like that, and you take that angle and you subtract it by the angle of inclination of line DO, which is DP, you see that you're going to be left with this angle over here. So this big piece minus that piece would eventually just get you to this angle. Okay, so we can clearly use this parallelogram here. So since we know that, and we know we just need this line ED, which is really just AD, so we need the gradient of this line, and then the other line that we need is DP, which is really just DB, and we just need the gradient of that line. We have the gradient of AD. Do you remember that in the beginning, they asked us to find the gradient of BC? If this is a parallelogram, these are parallel. Okay, so we can just note that down first. The gradient of BC is exactly equal to the gradient of AD. We don't need to state reasons. If it was Euclid, you'll tell them it's a parallelogram. So two pairs of opposite sides are parallel, but we don't need to do that. So we can just tell them the gradient of AD is equal to the gradient of BC, which is, of course, that gradient ED that we're looking at. Okay, so this is what we know. And so that gradient is equal to that gradient we found at first was -8. Okay, so we know the gradient of AD is -8. Great. And then we also need the gradient of BD. We found that. Remember when we were working with BP, proving that that was perpendicular to AC. So what is the gradient of BD that we found? Gradient of BD is 2. We have everything we need. Okay, so the gradient of BD is 2. Okay, so let me just draw that diagram down here. Okay, so just trying to find this angle over here. And so we can find the angle of inclination of line AD. And so we'll find that by saying tan theta, and I'll just call this theta of AD, okay, is equal to the gradient of AD, which is -8. And so to find this angle, we can find the angle and just round off to 3 decimal places, just to keep those decimals. Or 2 decimal places is fine because it is just round off to 1 decimal place. Okay, so then we can find this by transposing tan, and we'll have arctan -8. But you know that if you say arctan -8, you're going to get a negative angle. Now, we're not looking for that. We're specifically looking for this obtuse angle, okay, not that negative. So we'll add 180 degrees to this, and there we go. That's the 97 degrees that we can see there. Okay, so plus 180 degrees, and then theta of AD is equal to, and let's just see what that is. So it's 97.125. Okay, so we can leave it as 97.125 degrees. And then find the angle of inclination of BD. So we'll find that by saying from the x-axis that we're drawing, this imaginary x-axis, we'll go into the line BD. Okay, so that angle of inclination we'll find by saying tan theta of BD is equal to, and that gradient was 2. So theta BD is equal to arctan of 2. And let's see what arctan 2 is. So that is simply just 63.434. Or we can leave it as 435 and then just find this. Okay, so this is 63.435 degrees. And now finally to find that angle EDO. So this means that angle EDO is equal to, and we're going to take that bigger angle, okay, the angle of inclination of AD, 97.125 degrees, minus 63.435 degrees. Okay, and we'll just get our answer. And this is 33.69 degrees. So round off to 1 decimal place, and this is going to be 33.7 degrees. And that is our answer. Okay, moving on to the next question. Question 6.3 says, calculate the area of triangle ADC. Okay, let's just get our diagram so we can see this. So they want the area of this triangle ADC. Okay. Now, there are other things that we already know about this, so we can also just take those into account. Just remember this is 4, okay? K is 4. And if we want the area of this triangle, let's try using a half base times height first before resorting to other means of finding this area. So if we were looking at this using a half base times height, I will not try to find the height, looking at it this way. We could just find the height from the highest point of the triangle. And now do you remember that they already told us, or we were able to prove that BP was perpendicular to AC. Okay, so we've got a perpendicular bisector, okay? So these lines are perpendicular, meaning DP will now serve as the height. So if we find DP, we've found the height of this triangle, and then we can just go ahead and take AC as the base. So base and height, and that's all we need to find the area of this triangle. Okay, so seeing how they bisect at 90 degrees, this shape could either be a rhombus or a square. But that's not really that important in this case. I don't want to now go start proving the kind of shape it is to find just the area. So we can find the area by saying we need to find dp as the height. So the height, dp, is going to be found by just using the distance formula. We didn't really have the distance of anything else. In the beginning, they only told us what the distance of AB was. And they told us that was, square root of 65. That's not helpful. AB is not really, what we're looking at. Okay, so let's just focus on using the distance formula. So the base of that triangle is AC. Okay, we don't have DP, but we can just find DB. Okay, because this is the midpoint. So whatever DB is half of it. Okay, so let's find DB, and we'll say the square root of x2 minus x1. I'll just start with the negatives. So -2 minus 4 all squared plus -4 minus 8 all squared. Okay, and let's find dB so we can find dP. And that gives us 6 square root 5. So that means that dP is half of this. Okay, because that's the midpoint at P. So it will be divided by 2, which is 3 root 5. Okay, so we've got dP, and now we just need AC. So again, just use the distance formula to find AC. So AC equals the square root of, and we're saying A being -3 minus 5 all squared plus 4 minus 0 all squared. And let's just put this on the calculator. And AC is equal to 4 square root 5. Okay. And now we can finally find the area of this triangle. So the area of triangle ADC that they're asking for, ADC, is equal to a half multiplied by the base, which is AC. And we know AC is 4 square root 5 multiplied by the height, the perpendicular height of this triangle, which is dp 3 root 5. Okay, 4 times 3 is 12. 12 times a half is 6. So this is 6. And then square root 5 times square root 5 is just going to be 5 because they are the same thing. They become squared and it's just times 5, which is equal to 30. So 30 units squared. And that is our answer. And that is it for question 3. Question 4 says, in the diagram below, the equation of the circle with center N is this, okay? And then they tell us that QT is a tangent to the circle at T. T and P is the diameter of the circle. And we have point P, which is 5 and 4, lies on the circle. And 4.1 says, write the equation of the circle in this form. Okay, so to get the circle's equation from this form to its standard form, we're going to have to complete the square on this. So let's rewrite that first. Okay, and this is our equation. And now to complete the square. So you can rewrite this as x squared, and then everything with x, you're going to put that together. So this is minus 4x and plus y squared minus 2y, and we can transpose the constant. So it is positive 13. With these, okay, we're looking at this alone, and we're going to complete the square on each of these, the ones in terms of x and the ones in terms of y. So we're completing the square on this part. You see that you have to take the coefficient of x, which is -4, and then you multiply that by a half, or you divide it by 2. So -4 divided by 2 is -2. So this will be x squared minus 4x, and you're going to add half the coefficient of x, which is -2, and you're going to square that, okay? And then we're going to do the same thing to this part. So plus y squared minus 2y, and we're going to say plus half the coefficient of y, which is -1, and square that. Now, this is an equation. What you do on the one side, you must do on the other side. So we added by -2 all squared here. We'll also add by -2 all squared here. And then we also added by -1 squared as well. Okay, and now we can simplify this. So we're factorizing really. You see, if you had to, distribute that, you would get a trinomial, and if you factorize that trinomial, you would get this. So we're going to grab the x, okay, and the -2. You could take whatever is inside that bracket, okay, whatever was squared, -2, and you're going to say all squared. Because if you factorize that expression, it would have given you x minus 2 times x minus 2, which is x minus 2 all squared. Likewise with this as well, we have plus, and whatever has squareds, we're going to put them in this bracket. So it's going to be the y and then the -1 all squared. And here you just simplify this. Okay, 2 squared is 4, and then that's 1. So 5, 13 plus 5 is 18. And that is our answer. Okay, that is the equation of the circle in this format. Moving on to the next question. Question 4.2 says, write down the coordinates of n and the length of nt. So n is the center of the circle, what are the coordinates, and then the length of the radius. Okay, so not much calculation needed here. We can see the center of the circle when the equation is in this format. So the equation center is at, remember this is in the form of x minus a all squared plus y minus b all squared. And a and b are the x and y values of the center of the circle. So it means that the x value of the center is 2 and the y value is 1. So that's the coordinates of n. Now for the length of nt, the radius of the circle, the radius, this part is r squared. Okay, as you can see, they already wrote it in this format. R squared is 18. So if we know that r squared equals 18, then r is equal to the square root of 18, which is, we have a 9 here. 9 times 2 is 18. So that's going to be 3 root 2. Okay, so that is the radius. Okay, yeah, that is our answer. So this is the center. This is the length of the radius. You can just tell them this is nt, 3 root 2. Moving on to the next question. Question 4.3, determine the equation of the tangent QT in the form of y equals mx plus c. Okay, the usual questions when they give you a circle and a tangent. So to find the equation of the tangent, it's still a straight line. You still need the gradient and you need 1 point to find the y-intercept, c. So find the gradient using the points that you actually know on this graph. We know what n is. Okay, we found that should just be 2 and 1. So you can find the gradient of this line. Okay, we don't have t, but we can actually find it because we know the center, we know this point on the circumference, and we know that this is a diameter. So we can use the midpoint formula to find t, seeing that we already know what the midpoint is. Okay, so I'll call t, x, and y. Clearly, the first thing we need to do is actually find t. So let's find t first. Or we could find the gradient first. The gradient is fine. Let's find the gradient. So we'll find the gradient of this line, Pn. So P and N, let's write that down. So the gradient of this line is y2 minus y1. So that's 4 minus 1 over 5 minus 2. And so 4 minus 1 is 3. 5 minus 2 is also 3. So that's 1. The gradient is 1. Now we have the gradient. All we need is t. Okay, so let's find t. We're using this. Okay, and the relationship between the midpoints and the endpoints. Okay, just realizing that I didn't even need to write it like that. I could have just done this. So now we can find t using the midpoint. So we're saying the midpoint of this line. Here's the midpoint formula first. Okay, and we're saying that the midpoint of this line is 2 and 1. But to find the midpoint, the calculation for it is using the endpoints. So it's x1 plus x2. So that is x plus 5 over 2. And then y plus 4 over 2. Like we did in question 3. Okay, so this is what we have. And we're saying that these are the exact same point. Okay, so this is the actual point. This is the calculation, meaning their x and y values are the same. So x plus 5 over 2 is equal to this x value of 2. And y plus 4 over 2 is equal to this y value of 1. So multiply both hand sides by 2. X plus 5 is equal to 4. X is therefore equal to 4 minus 5, which is negative 1. And then y plus 4 equals, multiply both hand sides by 2, and transpose the 4. So y equals 2 minus 4, which is negative 2. There we go. It means that t is -1 and -2. Great. Now we have the gradient and we have t. We can find the equation of this tangent. So we have the gradient of the radius, okay, or the diameter, which is also the gradient of the radius. How do we find the gradient of the tangent? Well, we know that the radius and the tangent are perpendicular at their points of contact. So to find the gradient of the tangent, remember, still using question 3's ideas that they also threw at us there. Okay, they're following the same things, just still using the same things here. We're going to just say the gradient of our radius multiplied by the gradient of the tangent give us -1. Therefore, the gradient of this line QT, that tangent, would be equal to, just take the gradient of the radius and multiply it by -1 in this case, because it's just 1. Okay, so times that. So if the gradient of the radius was 1 and the gradient of the tangent is -1, you see that they do give us -1. Okay, their product is -1. So we know the gradient of the tangent and we have a point on the tangent. So to find its equation, we say y minus, I'll just use this equation, y minus y1 equals the gradient times x minus x1. So we're saying y minus, and this is y1, this is x1. So y minus -2, which becomes a +2, is equal to -1 multiplied by x minus -1, which becomes +1. And just simplify. So y is equal to -x and then -1, and that transposes and becomes -2. So that is -3. And that is the equation of the tangent to the circle. Okay, moving on to the next question. Question 4.4 says the circle with center S, A, and B touches the circle with center N externally at T. And then QT is a tangent to both of these circles, okay? And then if NS is equal to 3NT, determine the coordinates of S. Okay, let's get our diagram so we can just understand what's going on here. Okay, so this is what we have, and let's just remember that we do have a center here, that we know that N is 2 and 1. Okay, we already know that's 2 and 1. And so if this is 2 and 1, let's just look at the info they told us. We have another circle, and it's going to touch this circle externally, okay, at T. And we're told that NS, so wherever that S is, it is going to be 3 times the size of NT. That's really what it means. Okay, so NS is 3 times the size of NT. That would make the circle the bigger one. So this will have a larger radius, a longer radius. And so it touches with that circle. And then we have a center. Okay, so it means that we can actually just extend this line that we have here. Okay, because it is also going to be a tangent to the circle at T, to this new circle. It means now we have the center at S, which is A and B, and this is still a tangent to it. Here's why I said this is definitely going to be a larger circle. The radius is bigger because NS is 3 times the size of NT, meaning NS, right? That would get 3 parts, and then NT gets 1 part. So from that, you can see that TS would get 2 parts, so it's bigger than this. It's twice the size of this circle. Okay, this would be 2K, this would be K. 2K plus K is 3K. Okay, but that's not important right now. So all we're just trying to find is S using the information we have. Let's see a simple way that we could find, not really simple, it's still steps that we have to take. How could we find S? The thing with S is we can probably use distances, but S, A and B are not the same coordinate. So you see with the distance formula, if you're trying to find a missing coordinate, it's easier to find it if that coordinate has the same X and Y value, because it would mean that it would just be in terms of the same variable. Okay, it's like having A and A. You're just solving for A, okay? If we don't do it like that in a way that they have the same variable in their X and their Y value, you're going to need a simultaneous equation because you're finding 2 variables, 2 different variables. So you'll need 2 pieces of information, which will then create a simultaneous equation. So I'm trying to avoid that. Okay, let's see. How about we do this? Because they told us that NS is 3 times the size of NT, we know what NT is. We know the radius of the circle. So let's find the length of ns first. So ns is equal to what's nt? Nt was 3 root 2. We found that already. So it's 3 times the size of 3 square root 2, meaning ns is simply 9 square root 2. So we know what ns is. Now, look at what we can do. You see that in the previous question, we found the equation of the tangent, right? The tangent was, its gradient was negative 1. How about we just find the equation of this radius? Okay, this extended radius. Because they all lie on the same line, we could, once we found the equation in the form of y equals mx plus c, we can just substitute a in place of x to find the y value. Here's what I mean. So I'm going to take this. If the gradient of the tangent was negative 1, remember we found the gradient of the radius to be 1. So if the gradient of the radius is 1, then the equation of line ns equation would be y equals x plus c, okay? mx plus c, the gradient is 1. And then just substitute 1 point on this line ns to find its full equation. We can use t. We already knew t from the previous question is negative 1 and 2. So we'll substitute negative 1 and negative 2, negative 2. Okay, so that is negative 2 is equal to negative 1 plus c. And so c is equal to, transpose the negative 1. 1 minus 2 is negative 1. So the equation of this line ns is y equals x minus 1. Great. If you know that the equation of this line is x minus 1, the points s can be represented like this. S, the a value is just a. But here's what we could call the y value. Y can be equal to, it's going to be a result of substituting this x value of a into its equation. So it's going to be, in place of x, we'll say a minus 1. So it means that the point S is now simply, so the x value is a, the y value is a minus 1. It's a and a minus 1. And there we go. So the minute you get it to this point, it's in terms of the same variable. You can easily find the value of a. Okay, now all we need to do is use it like this. We can use the distance formula. ns, we already know the length of that line. It's 9 square root 2. So we're going to use the distance formula, and we already know what ns is, but we'll substitute in place of n, 2 and 1, and in place of s, we'll substitute this a and a minus 1. So I'll just change this already to a minus 1 as the y value. Okay, distance of ns. So we'll say ns is equal to, let's just put the distance formula down first. And so we're saying ns is equal to the square root of, so we're using n and s. So let's just start with the a's first. So this is going to be x2, meaning a minus 2 all squared, plus y2, which is a minus 1 minus 1 all squared. Okay, and we know that the length of ns is 9 square root 2 because ns was equal to 3 times the size of nt. Okay, so 9 root 2 is equal to, and all we're doing is simplifying here. Okay, this is the square root of a minus 2 all squared plus, that's just going to be a minus 2 all squared. I see that they're exactly the same. Great. We can just square both hand sides to get rid of this root. So square this and square this. And so 9 squared is 81 and square root of 2 squared is 2. So multiply by 2 is equal to, now this radical breaks open. But now do you see that these are the exact same thing? A minus 2 squared plus a minus 2 squared. If you put them together, just like if you had x squared plus x squared, it becomes 2x squared. This is going to become 2, and then whatever repeated, it was a minus 2 squared. Okay, this is actually an easier way to simplify this, because now we have 2, and you see 2, we can just divide both hand sides by 2 to get rid of that. So get closer to the a. So 2 divides here, and you're just left with 81. So we're saying a minus 2 all squared equals 81, and then square root. So square root this side, square root that side, and we have plus minus, and this is equal to. So we have a minus 2 is equal to positive or negative 9. And finally, a is equal to, we can transpose the negative 2, and it's now positive. So it's 2 plus or minus 9. So we can say plus 9, or a is equal to 2 minus 9. So a is either equal to 11 or a is equal to negative 7. Now we have to decide. Based on what we know about the circle, what is a? Okay, a is in the fourth quadrant, and you can tell them that. You can just choose which one you know is a. You don't really need to give a reason. It's not Euclid. But we can see, because this was drawn externally, touching T, and also a tangent, it would mean that it appears here. The circle appears in the fourth quadrant, or rather that center appears in the fourth quadrant. So it would mean that a, okay, the a value of S is negative. It's negative 7, because we'll have negative x values in this quadrant. Okay, great, we know that now. And let's find its y value. So the y value of this, remember how at first we just expressed the y value in terms of a. So y was equal to a minus 1. So that's what we're going to do to find the y value. So its y value is a minus 1. So that is simply negative 7 minus 1, which is negative 8. Okay, so there we go. It means that S, the x value of S, is this. Okay, it's weird how I said a of S. I should call this a is just equal to negative 7. So this is the x value of S. So I know now that the x value is negative 7 and the y value is negative 8. And that is our answer. And that is it for question 4. Okay, so I just try to avoid getting to a simultaneous equation. Okay, so that is our answer, and that is it for question 4. Question 5.1 says, in the diagram below, point P, which is negative 3 and negative 3 root 3, and reflex angle 2 theta are shown. And we need to determine, without the use of a calculator, the value of 5.1.1 cos 2 theta. So let's go ahead and complete our diagram so that we can find out exactly what cos 2 theta is. You see that we actually really do need all the dimensions there, because cos from SOHCAHTOA is adjacent over hypotenuse. Okay, from that car part. So we're going to need that hypotenuse. So we're going to go ahead and draw this line up to the x-axis. And then remember that it is perpendicular to the x-axis. And we can see that this is our x value of negative 3. So it means that from the center you went 0 and then you went 3 units to the left. So that is the x value, negative 3. And then the y value is negative 3 root 3. So you went down by negative 3 root 3 units. And so that is our y value. Okay, so we clearly have to just find that hypotenuse, OP. So we can find that using Pythagoras. So OP squared, being the hypotenuse, the longest side, is equal to the shortest side squared plus the other shortest side, negative 3 root 3, all squared. And let's see what we get here. So OP squared is equal to, this will be 9 plus, now when we square this, the negative 3 gets squared and becomes a 9, and then it's positive, of course. And then the square root of 3 also gets squared, but that will break open that root. So we have multiplied by 3. 9 times 3 is 27. 27 plus 3, that is 36. So this is what we have. And then if we square root both hand sides, of course, positive and negative, but OP is a length, so we can only just consider the positive, meaning OP equals 6 units. Okay, and now we can find out what cos 2 theta is. So if this is 6, cos, remember, is adjacent over hypotenuse. So it's the adjacent side, negative 3, over that hypotenuse of 6. So therefore, cos 2 theta is equal to the negative 3 over 6. And then this simplifies to negative 1 over 2. And that is our answer. Moving on to the next question. The next question asks us to find the value of sine theta. Okay, so you see that our reference angle is 2 theta. Okay, that's the angle we have in the diagram. So they want us to find sine theta. Okay, so they gave you double the angle of what they're asking for. So we can actually use double angles here. And you're going to think about a double angle that will include values that you actually have here, and it's going to have sine theta. Okay, so consider what your double angles look like, and I'll just put them down here. Okay, so these are our double angle formulas. Which one would be helpful to find the value of sine theta? We can evaluate this. You see, with this one, sine 2 theta is not bad. That's fine. We can actually find the value of sine 2 theta because we have 2 theta measured here. So you just have to use sine's ratio, okay? So opposite over hypotenuse. But then it starts becoming a problem where we have this cos theta. Yes, we know we're looking for sine theta, and we could just leave this on its own and then would be able to solve for this. But we don't know what cos theta is, okay? We're trying to find sine theta. We have no idea what cos theta is, and that's why we won't even consider that. Now, it means that we're going to have to use one of these. Instead of now searching from looking at this one, you'd figure out that what you are looking for is for a double angle formula that has sine theta but also has sine or cos 2 theta, because 2 theta is defined. We know what cos 2 theta is. We know what sine 2 theta is. We can find that, okay? But it becomes a problem when you're starting to look for something like cos theta. So from this, you see that the equation that would best help you here would be cos 2 theta is equal to 1 minus 2 sine squared theta. This is perfect to use because sine squared theta is there, meaning sine theta is there. You can make that the subject, and we know the value of cos 2 theta. It's equal to, cos 2 theta is equal to -1/2. Okay, so that's what we're going to do. Okay, so this is what we're going to use. And so our first goal is to make sine theta the subject so that we can find the value of sine theta. Okay, so how do we make sine theta the subject? We can transpose -2 sine squared theta, so it becomes +2 sine squared theta is equal to 1 minus cos 2 theta. And then we can divide both hand sides by 2. And we get sine squared theta is equal to, and at this point you can just substitute the value of cos 2 theta. We know that cos 2 theta from the previous question is equal to -1/2. So let's do that. We have 1 minus, and this is -1/2, and we have all over 2. Okay, so we're really just saying sine squared theta is equal to, and when we add there, that's 1 plus 1/2, which is 3/2. 3/2 divided by 2 is like saying multiplied by 1/2, which is 3/4. So this is our equation. And we're just trying to find the value of sine theta. Okay, so at this point, we can just square root both hand sides of this equation. So if you square root and you square root, remember this is sine squared theta, so it will have a positive and a negative solution, but that's not a problem because we already know where our terminal arm is. So certain things are defined here already. Okay, so this means that sine theta is either equal to positive or negative. So the square root of 3, remember the numerator and the denominator get square rooted. So that stays √3, but the denominator square root of 4 is 2. But let's decide based on what our diagram looks like. Do you see that our terminal arm lies in the third quadrant? This is where, so in this situation, this is 2 theta. So it means that this angle is a value greater than 180 degrees, but less than 270 degrees. So think about that. If 2 theta is greater than 180 degrees, but less than 270 degrees, then what is theta? Where exactly is theta? Well, you could just divide these by 2 just to find out what theta is. And so we could see that theta is greater than 90 degrees, but less than 270 divided by 2 is 135 degrees. Okay, so you see where that angle theta is going to lie. Greater than 90 degrees, but less than 135 degrees. So greater than 90 degrees, but less than 135. So it's in the second quadrant. And in the second quadrant, this is where sine is positive. So it means that sine has a positive value here. Okay, so that means sine is really just equal to positive √3/2. And that is our answer. Okay, so we could have also seen this visually because you see, if this is 2 theta, so theta is half of this. So if you divided this by 2, you would land in the second quadrant. Okay, so that is our answer, and moving on to the next question. Question 5.2 says, simplify the following expression. And we have this expression. Okay, let's first figure out the amount of terms that we have because expressions are simplified term by term. So expressions are always separated by plus or minus signs. And you see now throughout here, right, we have a plus sign. So it means that this is one term on its own and this is a whole term on its own. So we have two terms here we're simplifying. Let's start with the first term. So the first term is cos squared 180 degrees plus x. So from our cos diagram, we know that 180 degrees plus x is in tan's quadrant. So it means cos is negative here. So this is negative cos x. That's what it simplifies to. But this is squared. So it will still get squared and then become positive cos squared x. And then we have plus, okay, then we have cos negative x. Now the angle is negative. When it's negative, you can just add 360 degrees to this. So that would be cos 360 degrees minus x. And then once you reduce this, you see that 360 degrees minus x, this is in cos quadrant. So this stays positive. So it will stay positive cos x. Okay, so you see why it's important not to just look at that and say, oh, it's negative, I'll take out a common factor. That's not what happens. A common factor doesn't come out, okay? We are just applying the reductions to it. If it's negative, you add 360 degrees to that angle. And then we have tan x. Now, when you see tan x, you can just change it to its identity. You can see that we have causes here, so it's definitely going to cancel with something. So tan x is equal to sine x over cos x. So that's what we'll change that to. And then multiply by cos 90 degrees plus x. That is a cofunction. And so that one is the one that simplifies to negative sine x. Okay, so this is what we have. We have these two terms still. And let's see what simplifies. In this term, this just stays positive cos squared x. That's the first term. But in the second term, do you see that because we're multiplying all through, whatever is common diagonally will cancel. So it means cos x and cos x cancel. And you're left with positive sine x multiplied by negative sine x, which gives negative sine squared x. Okay. And you see that this, from the previous question, this is one of the double angle identities we have. So this simplifies to cos 2x, and that is our answer. Okay, moving on to the next question. Question 5.3 says, consider the equation 5 tan theta minus 6 cos theta is equal to 0. And 5.3.1 says, show that the equation can be rewritten as 6 sine squared theta plus 5 sine theta minus 6. Okay, so the difference I notice with this is that it only includes sine theta. It's in terms of sine theta. See, sine squared theta, sine theta. So that's what we can think about doing to this. So we have 5 tan theta minus 6 cos theta equals 0. We can change that to sine over cos. So this is 5 sine theta over cos theta and is equal to, we can transpose that. Okay, we take this over because we can just straight away multiply, okay, cross multiply, and that will get it to be an equation that doesn't have a fraction. So we have 6 cos theta and now cross multiply. See, this will be over 1. And so if you cross multiply, we're saying cos theta times 6 cos theta, which is 6 cos squared theta is equal to, and then that stays the same, 5 sine theta. Okay, so remember that there is no cos theta here. So we can just change this using the identity for cos squared theta. Cos squared theta is equal to 1 minus sine squared theta. So this is 6 times, and then we'll say 1 minus sine squared theta. And just remember that this comes from the identity sine squared theta plus cos squared theta is equal to 1. If you made cos squared theta the subject, then that's where we get the 1 minus sine squared theta. So it's equal to 5 sine theta. Okay, let's distribute. So we have 6 and then minus 6 sine squared. theta is equal to 5 sine theta. Okay, so they had the sine squared theta being positive, the 6 sine squared theta. So we can take that over to the right-hand side. And now we have 6 sine squared theta plus 5 sine theta, which is already on the right. And then we transpose that 6 and it becomes minus 6. And you see now how we have exactly what they have. You can say is equal to 0 here, or say is equal to 0. So there we go. And that's how we get it to this point. Moving on to the next question. Question 5.3.2 says, determine the general solution of the equation they gave us. Okay, so we'll take it like this and let's just rewrite that. Okay, so let's factorize this equation. So you can look at it in the form of this. So pretend sine theta is k. So this will be 6k squared plus 5k minus 6. Okay, and then you could factorize it like that. But I'm just going to factorize it in this form so we don't have to still substitute back. So we're looking for factors of 6 sine squared theta, and that will be 6 sine theta and sine theta, just testing for now. Okay, and then we need factors of 6 or negative 6 really that can give us negative 6. So that will be, if I put it like this, it's not going to work. So if I say 3 and 2 give 6, but I can see that that's not going to help to form the 5 in the middle, okay, the 5 sine theta. So let's break this one up and call this 3 sine theta times 2 sine theta. Okay, so if you multiply like this, that's just going to be, okay, so it won't work out like this either. That's just going to be 6 sine theta, and that's going to be 6 sine theta, but one of it needs to be negative. So you see how that will just end up canceling it out. So let's switch these around. Let that be 2 and let this be 3. Okay, so like this, that's going to be 9 sine theta. Okay, and I can see this is going to work fine. And this is going to be, when you multiply, that's going to be 4 sine theta. Now remember, one of it needs to be negative so that the 6 is negative. So we can give the negative to, we want this to stay positive so that this can be positive 5. So 9 minus 4 is 5. So we're going to give the negative to the factor that helped us to get 4 sine theta. So that's 2 sine theta times 2. So that takes the negative, this takes the positive. And there we go. 9 sine theta minus 4 sine theta equals 5 sine theta. We actually do get our middle term. Okay, so those are our factors. And we'll just say it's 3 sine theta minus 2 multiplied by 2 sine theta plus 3 is equal to 0. And all we have to do is solve for theta. Okay, find the general solution. This means that 3 sine theta minus 2 equals 0, or 2 sine theta plus 3 equals 0. And then here, if you transpose the negative 2, it becomes positive, and divide both hand sides by 3, then sine theta is finally equal to positive 2 over 3. Likewise here, transpose that 3, it becomes negative, and divide both sides by 2, sine theta is equal to negative 3 over 2. You can already see a problem with that. But okay, so yeah, let's just deal with the one that is going to be an issue. Here's why I say there's a problem with this. If you're on your calculator, right, try to find arc sine 3 over 2, not even the negative, okay, just the 3 over 2. You see, okay, my calculator will say I, yours will say error, okay, because there's no solution to this. Here's the problem. The problem is that we had sine theta being equal to negative 3 over 2, which is negative 1.5. This went below negative 1. It's impossible for that to happen with the natural sine graph. Okay, the graph sine theta looks like this, and the highest it reaches is 1 and the lowest is negative 1. So we don't have any solution by negative 1.5. Negative 1.5 is maybe somewhere here. You see that there's no graph below here. Okay, the graph does not have any x values for which its y value is negative 1.5, and that's the reason we don't have a solution there. Okay, so here we can simply just say that sine theta is not equal to negative 3 over 2. And now we can just work on this. So great, this is all we are working on. We're just trying to find the general solution for this. So it's a positive value. It's really simple. You can either use the Cartesian plane method or your sine graph to find this. Okay, I'll just use the Cartesian plane method. So we're just saying that sine theta equals 2 over 3. This is a positive value. So we're going to use the reductions where sine is positive. This is in the first quadrant and in the second quadrant. Okay, let's find our reference angle. So the reference angle when sine theta equals 2 over 3, we'll find out by simply saying arc sine 2 over 3. Okay, and at this point you can safely round off because you see how we just have theta here, not 2 theta or half theta or anything like that. So we don't have to consider dividing or multiplying by anything at the end. So we can just round off to 2 decimal places at this point. So this is 41.81 degrees. Okay, so we'll hold on to this and let's just solve. So using the reductions that we have, we're trying to solve for theta. The general solution is here we're going to use theta just as it is. So we'll say that theta is equal to 41.81 degrees. But remember, this particular solution on the sine graph will repeat itself every 360 degrees. We're trying to find the general solution, not the solution within a specific interval. So here we'll say plus k 360 degrees, okay? And then or theta is equal to, and then we'll use this reduction, 180 degrees minus theta, minus our reference angle. So we'll say 180 degrees, and we might as well just find it immediately. Just say 180 degrees minus this value. Okay, if it was rounded off, it's still fine. Okay, and that's going to give us 138.19. Even if you had rounded off, it would still be fine. It will still give you that answer. So it's 138.19 degrees plus k 360 degrees, because this answer will repeat itself every 360 degrees, where k is an element of integers. And this is our answer. Okay, so that is that. And moving on to the next question. Question 5.4 says, prove that, and we have, let's just look at what we have here, cos 2 alpha plus 77 degrees, cos alpha plus 407 degrees minus, I'm just trying to look for consistency with this because the way it looks is saying cos, sine. So you can see it's singing the cos song, okay? So we're going to use the compound angle formula for cos. And then this says sine, okay, alpha plus 47 degrees, similarity there. And then 2 alpha plus 283 degrees. So let's just see. Okay, so let's just rewrite this left-hand side because that's what we're working with. We just have to prove that this identity is true, okay? That all of this is equal to cos alpha plus 30 degrees. So let's rewrite this first. Okay, so when rewriting it and just looking at it for a while, there seems to be a problem with this question. So here's the thing. With the way it's structured, it looks like it's supposed to use the compound angle formula for cos. So because of that, it will mean that it goes in the form of cos, sine, and then this is your first angle. We can call that A, and then this is B, and then A, and then B, okay? But really this one is the A, and then that's the B, okay? But the thing about this is, if you try to simplify these angles, this one is perfect. It works out fine. If we simplify this, because it's 407 degrees, it's an angle that is greater than 360 degrees. Okay, so in order to just bring it back so that we can understand it, you can subtract 360 degrees from this. And if you say 407 minus 360, you see you get 47 degrees, which is good. Okay, so this becomes cos alpha plus 47 degrees. Great. And now you see how it ends up looking like that. Okay, so it is following this order. You just have to switch these two around, rewrite them. Okay, so it is still cos 2 alpha plus 77 degrees, cos alpha plus 47 degrees, sine alpha plus 47 degrees, which is fine. You see how they are the same. And that's actually what we want until we get to like this point. And it's not only this, actually. Well, but looking at this, right, this is 2 alpha plus 283 degrees. So clearly it was supposed to simplify to an angle that would also say 2 alpha plus 77 degrees. But because they used positive 83 degrees, this is now going to be a problem. So what could have been used here was the same idea we used here. You see how that was 407 degrees? And then when we take out 360, it becomes 47 degrees. Then this, right, could have been an angle 2 alpha plus 77 degrees. And this could have either had 360 degrees added to it or even 360 degrees subtracted from it, meaning it could have looked like this. It could have been 2 alpha, and then if it was 360 degrees subtracted from it, it would have looked like this. Okay, now this wouldn't be a problem. Negative 283 degrees would not be a problem, because to get it to look like this, you would simply just add 360 degrees. And if it was 2 alpha and then you added 360 degrees to that 77, it wouldn't have been a problem. It would have been 437 degrees, and this would still be fine. Okay, plus 437 degrees. This would have been fine because you would have just simply subtracted 360 degrees from it, and then it will look back like that. Okay, it will look like that. And then we could simplify that further. Okay, so this is what I'm saying. This is what it probably should have looked like. Okay, like this. Or of course 437 degrees, because you just have to subtract 360. But let's just go with this, since they actually did use 283 degrees. So that maybe should have just been negative. And then if we try to simplify this further, just so that we can see, because there was also another issue with this actually. Let's just simplify it further so we can see this. It should still be equal to this. This is an identity. The left-hand side should be equal to the right-hand side. Okay, so this is really just practice on simplifying it. When you would simplify this, it would stay cos 2 alpha plus 77 degrees. This one, as you saw, if we subtract 360 degrees from this, this becomes cos alpha plus 47 degrees. And then we have this, okay. Now, you can switch these around just so that it is in that order of the compound angle expansion, okay, with that cos A, cos B minus sine A, sine B. So this being that first angle, 2 theta plus 77 degrees, and this being the second angle. So I want this to appear in the second place. So since they're both sine, you can just move this one here. So it'll be minus sine. Now from this, because this is negative 283 degrees, all you would have to do at this point is just add 360 degrees. Okay, it's just a negative angle 283, and we add 360 degrees, and then we get 77 degrees, and then it's perfectly fine, because now it will just say sine 2 alpha plus 77 degrees, and then you see how these two are the same angle. Okay, so that will work out, and then we will rewrite this as it is. That one is fine. Sine alpha plus 47 degrees. So this is in the form of cos A, okay, that's our A, and then cos B, that is our B, and then sine A, sine B, okay? Okay, now in the same way that this would simplify to cos A plus B, okay, because we had a minus, this should also simplify to cos, and then our first angle is 2 alpha plus 77 degrees plus alpha plus 47 degrees, okay? So with this, now we start seeing a problem because they used minus here. So when you simplify it, it should become plus. If you add these, you see how we're never going to get to this. Okay, if you add these, you get cos 3 alpha and then 77 plus 47. Okay, so plus 124 degrees. You see how that is not identical to this. And we would have seen that this was a problem if you did this at first. So this is a little thing that I used to do in grade 11, just because when we'll be given expressions, you can't really see what the answer is at the end. But you can actually use a calculator to ensure that your answer is correct. And how you do that is you give a value to that unknown angle. So alpha, I'll just say, let's say alpha is equal to 0 degrees. And I'm going to substitute alpha as 0 in this part, and it should give me the same value as cos alpha plus 30 degrees if alpha is equal to 0 as well. Okay, so if we try that, let's see what we get on the calculator. Okay, so when I substitute 0 on the left-hand side, this is what I get. Okay, so 0 all through. You can try substituting 0 there, and we get 0.5986. Now, this should be consistent with the right-hand side. Okay, if you substitute 0 here, so cos 0 plus 30 degrees, we get 0.8660. And you see how these are not the same. Okay, so it means that there was an error in this question. Okay, so there was an error. And yes, I see this now. In the memo, they do say that this question has been removed from the question paper. Do not mark this question. Okay, so yes, there was an error in this question. If you still wanted to practice on this, then instead of making this 3 theta, okay, it shouldn't have become 3 theta. This should have been a minus, and then it would have worked out perfectly. So from the start already, if this should have been a minus, okay, it means that you should have had a minus b, meaning this over here should have said plus, so that when you simplify using compound angles, okay, then it should have said cos a minus b. So from here already, this should have said plus. So that would be the two things that you could adjust. You could adjust this angle by making this 2 alpha minus 283 degrees. And then you could also just adjust that. And then you'll see that it will actually work out. So if we did that and we change that to a plus instead, so just change it to a plus all through. If this is plus, then you see that we're going to get to this point where we say cos A, cos B plus, okay? And then we'll have to simplify it to cos A minus B. And so if this is cos A minus B, then this is actually going to work out perfectly, where we have 2 alpha minus alpha, which is alpha, and then 77 degrees minus 47 degrees, which is positive 30 degrees. And there we go. So in this case, the left-hand side would be equal to the right-hand side. Okay, so you could just adjust that to a plus, and then you can change that to negative 283 degrees, or you could also use 437 degrees. Then you would have to subtract 360 degrees from this. But in this case, you would have to add 360 degrees to this negative angle. Okay, so that's how I would solve that question if it had those in it. Okay, it would just be like that. That should just be minus, and there we go. Moving on to the next question. Okay, question 5.5 says solve for alpha and beta, and we are given that sine 3 alpha minus beta equals 1 over root 2 if 3 alpha minus beta is an element of 90 degrees to 270 degrees. Okay, so we're just going to have to see which quadrant it lies in. You see that it has this type of fixed value, okay? So with special angles, really, that one. So we can actually find these values, okay, what the value of 3 alpha minus beta is. It will be equal to a specific angle, and so will 2 alpha plus beta, okay, because it's equal to 1 over root 3. It's using tan, and they also tell us the quadrants. Okay, so here's how we can find this. Let's just look at the first one. Sine 3 alpha minus beta equals 1 over root 3. And this is an element of 90 degrees to 270 degrees. So on the Cartesian plane, just marking where this angle is specifically. It's an angle that is greater than 90 degrees, but less than 270 degrees. Okay, so it's either in the second or the third quadrant. But please notice that they say that sine of that angle is equal to 1 over square root 2. Okay, so it's a positive value, meaning sine is positive in this quadrant. So that would mean that sine would lie here in the second quadrant, okay? Because we're looking at between the second and the third quadrant. This is where sine lies. Okay, so we'll take this sine 3 alpha minus beta equals 1 over root 2. And let's find the reference angle of this equation. Because it's 1 over root 2, you're simply saying that the reference angle is equal to, and it's like transposing sine. So let's find out what arc sine of 1 over root 2 is. That's 45 degrees. Okay, you can also use the calculator and still say shift sine and then 1 over root 2. Okay, it's 45 degrees. So You can't just use the triangles, the OHA rule, or the circle. But since we know this is 45 degrees, the reference angle is 45 degrees. But we can clearly see that 3 alpha minus beta, this angle we're referring to, because this is positive and it's either between the second or the third quadrant, but we know it's in the second quadrant because sine is positive in the second quadrant. If our angle is 45 degrees, we're going to use sine's quadrant to find out what 3 alpha minus beta is. Okay, there's no confusion. We're not saying we're using the first quadrant or the second quadrant. No, we're only using this quadrant because this told us you must choose between the second or the third quadrant, but we know it's the second because sine is positive. So this is 180 degrees minus theta, and so we're going to say that this value, the angle, okay, there, 3 alpha minus beta is equal to 180 degrees minus our reference angle, which is 45 degrees. Okay, so it means that 3 alpha minus beta equals, that will give us 135 degrees. Okay, so this is our first equation. 3 alpha minus beta equals 135 degrees. And then let's find an equation as well for this one. So this is tan 2 alpha plus beta. So we're doing the same thing over here. Tan 2 alpha and then plus beta. So 2 alpha plus beta. And this is equal to 1 over root 3. Okay, let me just find out. We need to find that reference angle here. Okay, so the reference angle here is, we'll say arc tan and 1 over root 3. So that's 30 degrees. Okay, so with 30 degrees, we're saying that the reference angle is equal to 30 degrees. That doesn't mean that's what this angle is. You see, with this as well, they told us, yes, tan of this angle is equal to 1 over root 3, but they specifically said if the angle that we are referring to is greater than 90 degrees but less than 270 degrees. So it's also either between the second or the third quadrant, greater than 90 but less than 270. But you can see that tan is a positive value. So tan is in the third quadrant. And the third quadrant reduction is 180 degrees plus theta. So to find this value, we'll say this means that 2 alpha plus beta is equal to, and we'll say 180 degrees plus 30 degrees. Normally at this point we say plus k 360 degrees, but you see with that we don't have to do that because we already have a diagram, so we know exactly where those angles are. Okay, so now we have two equations. This, of course, if you simplify this, this will say 2 alpha plus beta is equal to 210 degrees. So we have two equations. We have this equation and we have this equation. And all we're trying to do is solve for alpha and beta simultaneously. Okay, so in both equations, beta is nicely on its own. So let's just make beta the subject. So let's take this equation again. At this point, you can simplify it in any way that you want to. You can add both equations. You can't say this equation minus that equation. That's fine. Okay, but I'm just going to make beta the subject by transposing it. So it becomes positive beta here. And then we have 3 alpha minus 135 degrees. Okay, and then our second equation for beta, I'll just make beta the subject there. So leave it on the left-hand side. And that's beta equals, and we still have 210 degrees, and we'll transpose the 2 alpha. So minus 2 alpha. Okay, so we have beta and we have beta. So I'll say therefore beta is equal to beta, and that is 3 alpha minus 135 degrees is equal to 210 degrees minus 2 alpha. And now we can transpose that. So that's going to become plus 2 alpha. So we have 5 alpha, when it adds to the 3 alpha, is equal to 210 plus 135 degrees. That gives us 345 degrees. Okay, so that's 345 degrees. And then divide both hand sides by 5. Therefore, alpha is equal to, let's see what that just gives us. 345 divided by 5 gives 69 degrees. So this is 69 degrees. And there we go, we've solved for alpha. And now we have to find beta. So beta is equal to 210 degrees minus 2 times, and that is alpha, so 69 degrees. And beta is equal to 72 degrees. And that is our answer. Okay, alpha is equal to 69 degrees, while beta is equal to 72 degrees. And that is it for question 5. Question 6 says, in the diagram below, the graph of f of x is equal to 2 cos x is drawn for the interval where x is an element of negative 90 degrees to 180 degrees. And 6.1 says, draw the graph of g of x, which is equal to negative tan 3 over 2x for the interval, okay, the same interval, on the grid provided in the answer book. Clearly show all asymptotes, intercepts with the axes, and endpoints of the graph. Okay, so this is a tan graph. To draw this graph, okay, we can just use the simple approach. The simple approach would be to remember what all the critical points of your tan graph are. Okay, so let's look at the graph of y equals tan x. And I'm not going to go into this too much because there's actually a really simple way to do this. Remembering what the tan graph looks like, this graph will first have an asymptote. Let's just put down that asymptote and remember where that is. That would be at 90 degrees. Okay, so we have an asymptote at x equals 90 degrees. And then the graph will look like this. So from 0 degrees, it's going to shoot up and move closer and closer to that asymptote. But here we have another important point. So we need to note down all these important points, okay? And that's really the points they are referring to. The asymptotes, the intercepts with the axes, the endpoints, okay? So these are these points. Where we have x-intercepts, so the graph intersects with the x-axis, that's where the graph is equal to 0. Okay, it has a y value of 0. We would also have to look for any y-intercepts. So this would specifically be where the graph has x values of 0. Okay, and lastly, the other points that would be important, or the other thing important, would be your asymptotes. So let's just watch out for these things. We know that a tan graph will look like this, but I would also like to point out another point that is important on the tan graph. And this is specifically where the tan graph has a y value of 1. And that happens at 45 degrees. So at 45 degrees, the tan graph reaches 1. Okay, the graph of y equals tan x. And then another important point would be where the tan graph reaches negative 1. Okay, so negative 1. It's best to put these down because they will probably ask questions about it when you go through your questions in this section. And it reaches 45 degrees. Just see how it reaches it. Okay, from 0 degrees, okay, and then to this point, 45 degrees. This graph looks like this. And then it goes closer and closer to the asymptote, but never touches it. So do you see that it took from 0 degrees to 45 degrees to reach a y value of 1? Remember, the tan graph completes a cycle within 180 degrees. So from 0 degrees to 180 degrees, it has completed one cycle. And this is also the point where it will have a y value of 0. Now, if it took from 0 to 45 degrees to the right to reach a y value of 1, then when its y value is 0 at 180 degrees, it will go 45 degrees to the left, and then that is where it will reach a y value of negative 1. Okay, and that will be at, you just say 180 minus 45 because we're going 45 degrees to the left. So that's at 135 degrees. So you see, these are important points that we need to have, where it has x-intercepts, y-intercepts, asymptotes, and where it's equal to positive or negative 1. Let's just keep that in mind. Okay, now looking at our graph, this is negative tan 3 over 2x. I'm only going to specifically look for these important points. Okay, now just note that this has a coefficient in front of x. When you do that, it's going to tamper with the period of the graph. Remember how the tan graph has a period of 180 degrees naturally. But now the new period will be found by saying the old period divided by whatever is in front of x, which is 3 over 2. We could just say 180 degrees multiplied by 2 over 3 using tip and times. And 180 and 3 have 3 in common. So 180 divided by 3 is 60 degrees. 3 divided by 3 is 1. 60 degrees times 2 is 120 degrees. This means that this graph is now going to complete a cycle within 120 degrees. So what it's doing over here, it will just go from 0 to 120 degrees. Okay, let's get plotting and just find these important points. So we want to find where the x-intercepts are, where the graph is on the x-axis. Okay, so that's going to work like this. You see how the period, we just took that value, the x value, and we divided it by 3 over 2, right? That's what's going to happen to all these x values. Their y values will stay the same. Well, of course, they will have a negative in front of it, but they're going to occur at different x values now. Okay, now let's just look at this. You see, there's a very simple way to do this, and I guess I'll call it the lazy way to do it. And it takes zero understanding of the graph and how it looks. You could simply just do this, and then in place of x, just substitute all these x values. Okay, at 0, you substitute 0, and then you find out what that y value is. So that will be 0 and 0. At 30 degrees, substitute 30. You just say, okay, that is 30, and then I have a y value of -1, and I'll plot that. And then at 60, you plot 60, and then you see it says complex infinity, so it means that there's an asymptote there. And then at 90, you just plot 90 and then tells you 1. You could do that as well, okay? And your graph will be complete. So you can do that, but if you want to actually just understand the transition, you can do it like this. So we're only going to focus on those important points, where it reaches 0, where it reaches 1, and our asymptotes. Okay, so at 0, you see that we're just going to take all these x values, just like we did with the period. And you're going to take all these x values and they're going to be divided by 3 over 2. So if you said 0 divided by 3 over 2, it will stay 0. Then the next point that would be important would be at 45 degrees. Something happens at 45 degrees. The y value of tan x at 45 degrees is 1. Now for this graph, g of x, which we can clearly see that there's a negative in front of tan, it will not be at 1 anymore. Since we have negative in front of tan, that means that the y values of this graph get multiplied by -1. And so it will not have that y value of 1 at 45 degrees. Its y value would be at -1. So now we know that, but now we also see that this appears at 45 degrees. All the angles on this new graph will change. It's not going to appear at 45 degrees anymore. Let's see where we will have a y value of -1. It should have been at 45 degrees, but the new place would be at 45 degrees divided by 3 over 2. Okay, all the angles just get divided by 3 over 2 and their y values stay the same. So if you said 45 divided by 3 over 2, it gives us 30 degrees. So it means that at 30 degrees, this is where we'll have a y value of -1. Okay, so we're done with that. And then another important feature that we'll have to look at is that asymptote. The asymptote appeared at 90 degrees normally. Okay, where is it going to appear on your new graph? Again, take that angle, 90 degrees divided by 3 over 2. Okay, if you say 90 divided by 3 over 2, it's clearly going to be 60 because at 45 degrees, we are 30. So 90, 60, okay? So we have 60, that's where the asymptote would be, and we'll draw our asymptote. Okay, so this is an asymptote here at x equals 60 degrees, and I'll just put that down so we know that. And then another important point would be where it has a y value of -1. Now notice we had negative in front of tan. So this y value of -1 will not be at -1 anymore. It will now be at -1 times that negative, which is going to be at +1. So we will have at 135 degrees, we should have a y value of +1. But remember that this has 3 over 2 in front of it. So what should have been 135 degrees and +1, this is going to change. And to find out what exactly this x value is, since the period has been tampered with, we're going to just say 135 degrees divided by 3 over 2. Okay, if we say 135 divided by 3 over 2, we get 90. So that is where that y value of 1 will be, at 90 degrees. So over there. Okay, and then last point that is important would be at 180 degrees. This one is simple because we knew that the period was 120. So it means that instead of it having a y value of 0 at 180 degrees, it will have a y value of 0 at 120 degrees. So at 120 degrees, it reaches 0. And so it still follows the shape of a tan graph and the way the tan graph looks. But now it goes from 0 to -1 and then it shoots down. So it looks like this. And then it goes from 0 at 120 degrees and then it's going to hit 90 degrees at 1 and then there we go, like that. And once you've got this part right, you can just draw the rest of the graph. This is a tan graph. It repeats itself every 180 degrees, but this has been manipulated so that it repeats itself every 120 degrees. So you're just going to repeat all these points again 120 degrees later. So this y value of 0 at 0 degrees will repeat itself 120 degrees later. That's where it repeats. This y value of -1 at 30 degrees will repeat itself 120 degrees later. So 30 plus 120 is 150. That's where it repeats itself. This asymptote at 60 degrees will repeat itself 120 degrees later. 60 plus 120 is 180 degrees. So you have another asymptote here. Okay, at x equals 180 degrees. Then this y value of 1 is going to repeat itself 120 degrees later, and you see that our interval does not go beyond this. So from here, your graph is just going to connect like this. It's going to move closer and closer to the asymptote, but never touch. Okay, so we're done with that part. Just always make sure you remember what the first part of your graph looked like. It was this part. Because we know that this is what repeats itself, you could just focus on this part and you would see that this same shape will repeat itself over here. Okay, so now we could also just do the same thing here. Looking at this and where it's going to repeat, we have 0 degrees, that's going to repeat 120 degrees before this. So 0 minus 120 is -120. That's beyond our interval. If we were trying to see where this will repeat, okay, it will be 120 degrees later. But if you said 30, so 30 degrees minus 120 degrees, that gives us -90 degrees. So we see that this y value of -1 is going to repeat at -90 degrees. And then we'll have this asymptote repeat 120 degrees before this. So 60 minus 120 is -60 degrees. So that's where that repeats. Okay, and then this is our graph. X equals -60 degrees. And so it's going to take this same shape that we saw. You see how it goes from 0 down like that to -1 and then shoots closer and closer to the asymptote. The only thing is we cannot see where it's equal to 0 because it's beyond our interval. So it's just going to go from here and then shoot closer and closer. And then you see here, if you just kept going, and you will see that these ones would just repeat themselves 120 degrees before this. So 90 minus 120, that's going to be at -30. Okay, so at -30, that's where we're going to have a y value again of 1. -30 and 1. And then you see how that completes that. So from here, it just hits 1 and gets closer and closer to the asymptote. Okay, so again, you could have just done this the easier way by taking this graph and substituting all these x values, and you would have gotten that. I honestly wouldn't blame you if you decided to do it that way because it's just less tedious. Okay, and that is what our graph looks like. Moving on to the next question. Question 6.2 says, determine the period of G. And we already discussed how the period of G comes about because of this 3/2. And, that kind of makes me feel like, did they actually want us to sketch this graph with, the reasoning of how the tan graph works? Not sure, but that's fine. We can just say the period of this graph will be found by simply saying the old period, which the tan graph has a period of 180 degrees, divided by that coefficient of x. So that's divided by 3/2, which is equal to 120 degrees. And that is our answer. Moving on to the next question. Question 6.3 says, write down the values of x in the interval, okay, in that same interval, for which f is decreasing. So f is decreasing. So that is this first graph that was already drawn. Where's it decreasing? So looking at the graph, you see that from -90 degrees, this graph is moving upwards when reading from the left to the right, meaning it's increasing here. And then it reaches that maximum, and then it starts to decrease. So it's decreasing all through here, and we just need to tell them the values of x for which this happens. So it starts at, or really just after 0 degrees, and then values that are less than 180 degrees. So this is where x is greater than 0 degrees, but less than 180 degrees, and that is our answer. So we'll tell them x is greater than 0 degrees, but less than 180 degrees. We could also write them in intervals. So it could be like this. You could say x is an element of, and we're going from 0 degrees to 180 degrees. But notice that 0 degrees and 180 degrees are not included values. So you would use round brackets. And that is our answer. You can write it like this or like this. Moving on to the next question. Question 6.4 says, Use the graph of g to determine for which values of x will g of x be greater than or equal to 1. Okay, so for that interval, greater than or equal to 1, and we're referring to the graph of g. Okay, so g. Where is it equal to 1? That would be at this point over here. That's where it has a y value of 1. That's where it has a y value of 1. And then values that are greater than 1, okay, would be from here and then all through here. So you see that the parts of the graph where it is greater than or equal to 1 would be parts of the graph above this line, y equals 1. Okay, so that's over here and over here. And now we just have to tell them the values of x for which this exists. So from this first part, we can see that that is where we have x being greater than negative 60 degrees, not equal to because we have an asymptote there. Okay, and then values that are less than or equal to negative 30 degrees, because at negative 30 degrees, the y value is 1. Okay, so the first part we have is here where we can tell them x is greater than negative 60 degrees, but less than or equal to negative 30 degrees. Or, and then the second part is over here, so we can just line these values down to the x-axis. These points on the graph, okay, lie between values that are greater than 60 degrees, but less than or equal to 90 degrees, because at 90 degrees, we have a y value of 1. Okay, so that is where x is greater than 60 degrees, but less than or equal to 90 degrees. And that is our answer. Of course, you can write this as intervals, so this would be x is an element of going from negative 60 degrees to negative 30 degrees. But by negative 60, because it's just greater than negative 60, not equal to, use a round bracket. Here it is equal to negative 30 degrees as well, so square bracket. Or you could have said x is an element of, we'll just say union, and then we're going from 60 degrees to 90 degrees. Same thing over here, use a round bracket here and a square bracket here, and that will be our answer. You can write it like this or like that. Moving on to the next question. And then the last question for question 6 says, 6.5, the function h is obtained by translating the graph of g 30 degrees to the right. Write down the equation of h. Okay, so this is a horizontal movement. We're going to the right. When you move to the right, okay, you're going to subtract. You move to the left, you're going to add. So we know we're subtracting by 30 degrees. And remember, the left or right movements, these affect the x. Okay, if a point moves from here and it moves to the right, the only thing that will change in this x and y coordinate is the x value. See how the x value changed from this to this. Okay, so let's see what the graph of g look like. We're taking h of x, and it's going to be formed by taking the graph of g and then translating it 30 degrees to the right. So we're going to take the x, right? The x values, and we're moving it 30 degrees to the right. So wherever you see x, just subtract by 30 degrees, okay, on the graph of g. So the graph of g of x, that was this graph, negative tan. So we're just going to say h of x is equal to, this is negative tan 3 over 2x. But you're going to have to subtract 30 degrees from the x, not from the 3 over 2x. So it works like this. We'll say 3 over 2. And then in place of x, just replace that with x minus 30 degrees. So where this should have just said x, okay, x, I replace it with x minus 30 degrees. Okay, so like that. And then we close that. So let's just apply that in there. So h of x is equal to negative tan, and we'll have 3 over 2x, and 3 over 2 times negative 30, 3 over 2 times 30, that's going to be 90 and divided by 2, which is 45. So minus 45 degrees. And that is what h of x looks like. And that is our answer. And that is it for question 6. Question 7 says, in the diagram below, AB is a pole anchored by 2 cables at C and D. B, C, and D are in the same horizontal plane. So those are just the ground. Like you could have people on the ground there. You see that is the floor. And so this is the cable connected to the ground there and the ground there. The height of the pole is h, and the angle of elevation from C to the top of the pole A is theta. And then angle CAD is equal to 2 theta and AC is equal to AD. And they want us to determine CD, the distance between the two anchors in terms of H. So just find CD. How do we find CD? Okay, looking at CD, since it's part of this triangle, to find CD, we have the angle opposite it. And we also know that, because I don't want to now find an angle. There's no need to find one single angle. We know that these two sides are exactly the same. So if we find one of it, we could just use the cos rule to find CD. So with the cos rule, because we're looking for CD, you see that we have the angle right opposite it. All we would need are the two sides next to this available angle. Okay, so we just need AC. AC seems easier to find because it's part of a triangle that we have here. And okay, we can find AC because we have theta and the side opposite it. It's in terms of H, okay? That is H. So let's find AC first. And because we have the opposite side and we're looking for AC, this is the opposite. AC is the hypotenuse. You see that we're using opposite and hypotenuse, meaning we're using sine. So we'll simply just say sine of that angle, theta, is equal to the opposite, which is H, over, so equal to H over this hypotenuse, which is AC. Okay, so at this point, we can just make AC the subject of this equation. You can choose to just cross multiply them, or you can just transpose. So if you transpose AC and it was in the denominator, when you transpose it, it will be in the numerator. So AC is equal to, now this sine theta is actually in the numerator because its denominator is 1. So if you transpose it, it will go to the denominator. So you still have H and then over sine theta. Okay, so now we have an expression for AC in terms of H, and we know that AC is equal to AD. So this is also H over sine theta. So we can also just tell them AD is also equal to H over sine theta. And now let's find CD. Okay, I'm just moving that over to this side. Using the cos rule, we'll say CD squared. Okay, so this is the side we're looking for. CD squared is equal to AD squared plus AC squared. Okay, we could just say AC squared plus AD squared minus 2 multiplied by AC times AD, and then cos of that center angle, the angle opposite CD, the side you're looking for. So that's cos 2 theta. And let's just substitute these values. So we're looking for CD. CD squared is equal to, we will just square root both hand sides. So we can just say CD is equal to the square root of, and so we'll just find what this is. So AC is H over sine theta. H over sine theta all squared plus H over sine theta all squared. And so this is what we have. Then minus 2 multiplied by H over sine theta and multiplied by H over sine theta again. H over sine theta. Then we have cos 2 theta. Cos 2 theta. And so we're square rooting all of this. So now it just has to do with simplifying. Let's just see how we can best simplify this. So we have square roots here, but I also noticed that if you add these together, because they're the same thing, they will really just become 2 and then H over sine theta all squared. It's like having x squared plus x squared. It just becomes 2x squared. So that base is still squared. And then we have minus 2 multiplied by, now these are the exact same thing. So they really just multiply and get squared. So it's just H over sine theta all squared. And then cos 2 theta. I'm just trying to keep what I can see is similar. Okay, so you see how those look alike? But you see, this is one single term. So it's not like they can just cancel, okay? Because we still have cos 2 theta there. So what we could do is, because we're square rooting this, we could just take out this H over sine theta all squared out as a common factor. Okay, I'm just looking for a quick way to simplify it instead of like simplifying the whole thing so that we just don't have terms that are quite long. So we have CD is equal to, and I'm going to take out h over sine theta as the common factor. So inside this radical, of course. So this is h over sine theta all squared. That's what I'm taking out as a common factor. Okay, this. And so if you take that out as a common factor, these, we have two terms here. This is the first term. There's the minus sign separating, and then this is the second term. So what is left in this radical? What we will be left with in the first term, as you can see, is just that 2. So we have the 2 there. And then in the second term, what are we left with? If we take this out as a common factor, you're left with this minus 2 and then cos 2 theta. Okay, that's what we're left with. So this is what this looks like right now. And it's still being square rooted. So here's the thing. You see how they are multiplying. So we can actually find the square root of this and the square root of that. That can't be square rooted right now, so we'll just leave it like that. So the square root of h over sine theta all squared, that is simply equal to h over sine theta. Okay, the squared is gone now. So this is outside the radical, and then we still have the square root of 2 minus. Now, you see cos 2 theta, it's a double angle. So you could use one of the double angle expansions, but it's going to be important to make sure you use one that can help to get rid of this 2 here. This is a distraction right now, and because of this, we can't really square root what we have here. Using double angles means you're going to have a square as well. It will be either sine squared or cos squared. So what we could do is, because we have a positive 2, ensure that the identity for cos 2 theta that you take is going to include something that will help to cancel out this positive 2. Now notice there's a coefficient of negative 2, okay? So it means that if you take an identity that results in having a minus 2, you will have that 2 minus 2 and they will become 0. And that's what we're trying to do there. So the best identity for cos 2 theta to go with here would be 1 minus 2 sine squared theta, because you already have a negative 2 here. So that's going to multiply with this positive 1 to become negative 2. And that's how it's going to create that case where it cancels out that positive 2 here. So we have minus 2 multiplied by, and we change this to 1 minus 2 sine squared theta. And now this is equal to, we're just simplifying further now, h over sine theta square root of, and we have 2, and this is going to distribute in. So minus 2, and then that distributes in and becomes plus 4 sine squared theta. And there you go. You see, these cancel, and we are just left with the square root of 4 sine squared theta, which can be square rooted. So h over sine theta multiplied by, and this is now the square root of that. Square root of 4 is 2. Square root of sine squared theta is sine theta. Okay, and then in the numerator and denominator, because these are common, they're going to cancel. We're multiplying. So that cancels with that. And our final answer for CD is simply h times 2, which is 2h. And that is our answer. Okay, and that is it for question 7. Question 8 says, in the diagram below, P, Q, R, and S are points on a circle with center O. UV is a tangent to the circle at P, PR and OS intersect at T. RQ is produced to W. And then they give us an angle. They tell us that angle PQR, that this is 106 degrees. And SP is equal to SR. And then the questions say calculate with reasons the size of the following angles. And we need to find angle PSR. Okay, so angle PSR is this angle over here. How do we find this? Looking at the diagram. Do you remember that P, S, R, and Q, they're all on the circumference of the circle. So this is a cyclic chord. And in the cyclic chord, we have an exterior angle. So the exterior angle of a cyclic chord is equal to the opposite interior angle. And so angle PSR, we'll tell them PSR is equal to 106 degrees because of the exterior angle of a cyclic quad. And that is our answer, and that's our reason. Also make sure to write down whatever you have found in your diagram. This is 106 degrees. And moving on to the next question. The next question, question 8.1.2 says we need to find the value of angle R3. Okay, so where is angle R3? Angle R3 is over here. And do you see that it's part of this triangle? And this triangle is clearly an isosceles triangle because we have two sides being equal. Okay, so we can find it because angle R3 would be equal to angle P4. The angles opposite those equal sides would be equal. Okay, so let's go ahead and tell them that these two angles are equal. They already gave us that these two sides were equal, so we don't really have to state those. So tell them angle R3 is equal to angle P4, and this is because of angles opposite equal sides are equal. Okay, so now that those are equal, we can work on adding these angles up, and because they're inside a triangle, they add up to 180 degrees. So that's 106 plus angle R3 plus angle P4. So we'll say 106 degrees plus angle R3 plus angle P4, and they give us 180 degrees, and this is because of this sum of interior angles in the triangle add up to 180 degrees. And then we can go ahead and add. Okay, so in place of angle P4, we'll just replace this with angle R3 since they're equal, because we're just trying to make angle R3 the subject. So this is going to be angle R3 plus angle R3, which makes 2 angle R3 is equal to 180 degrees. And so 2 angle R3 equals 180 degrees minus 106 degrees. Okay, so that is 80 minus 6 degrees, which is 74 degrees. And then divide both hand sides by 2. And therefore, angle R3 is equal to 37 degrees. And that is our answer. Okay, so we can also make sure that we just put this down in the diagram. This is 37 degrees, and this is also 37 degrees since they are equal. Okay, and that is our answer. Moving on to the next question. The next question, 8.1.3, says we need to find the value of angle P5. So angle P5 is over here. How do we find angle P5? Well, we can see that angle P5 is between this tangent and this chord PS. So it means that it's going to be equal to the angle at the circumference supported by the same chord, okay, which we can see is angle R3. So angle P5 is also equal to 37 degrees. And we can just tell them angle P5 is equal to 37 degrees, and this is because of the tan chord theorem. Okay, so that is our answer. Moving on to the next question. Next question, 8.1.4, says find the size of angle O1. And let's see. Angle O1 is at the center. Okay, it's here. Now, let's just speak about this quick. You see that there are two angles at the center. One hasn't really been named, so we're not going to focus on it. But with the angle at the center, just remember the arc that supports this angle. So angle O1 at the center, it's been supported by this arc PR, okay, which we can see is the major arc. It's the bigger arc to this arc PR. So since it's supported by this arc, do you see another angle at the circumference that is also supported by this arc? That would be angle S. That's also supported by that major arc PR. So we can go ahead and say that the angle at the center is twice the size of the angle at the circumference because they're supported by the same arc. Okay, so this means angle O1 is twice the size of the angle at the circumference, 106 degrees, because they're supported by the same arc. So we'll put our reason down. Okay, and so therefore angle O1 is equal to, and that is 212 degrees, and that is our answer. You can also make sure to fill it in because it will probably help you. So 212 degrees. Okay, so that is our answer. Moving on to the next question. The next question, 8.1.5, says we need to find the size of angle P3. So angle P3, that is over here. So based on where it is by the tangent. Do you see that the line from the center of the circle, okay, to P, that is a radius. So we know that the radius and the tangent are perpendicular at their point of contact. So it means that all of these should add up to 90 degrees, and that is because the radius is perpendicular to the tangent. So angle P3 plus 37 degrees plus 37 degrees give us 90 degrees. And of course, this is because the radius is perpendicular to the tangent. Okay, so let's find this. So 37 plus 37 is 74. So angle P3 equals 90 degrees minus 74 degrees, which is 16 degrees. And that is our answer. Okay, moving on to the next question. Question 8.2 says, in the diagram below, A, B, C, D, and E are points on the circle centered at O. Okay, so where you see 4 points on the circumference, that makes up a cyclic chord. So we can see we have a cyclic chord there, but of course we have 5 points on the circumference. And then they tell us that AC, OC, and ED are drawn. Chords BC and CD are equal, and we are told to let angle CED equal x. Okay, so 8.2.1 says, determine with reasons 2 other angles which are equal to x. So looking at this diagram, remember that x is at the circumference and it's supported by this chord CD. Do you see that we have another angle at the circumference also supported by this chord? And this is angle A2. It's also supported by CD. So they would be equal. So we can go ahead and tell them, okay, this is x. So angle A2 is equal to x because these are angles in the same segment. Okay, they're supported by the same chord and they lie at the circumference. And where else do we see another angle equal to x? Okay, so do you see that CD, right? The size of CD and the size of BC are exactly the same. If we have this situation, they're being supported by a chord of the same length, meaning they would also support equal angles. It's just like with this case, you see how they're supported by the same chord because that chord is the same length. So these would also be equal as well. So that is also equal to x. And the reason for this one, it's not really angles in the same segment. Rather, it is a corollary of angles in the same segment. It's one of those theorems that come from it. So for this, we can say equal chords support equal angles at the circumference. Okay, so we'll tell them that angle A1 is also equal to x because equal chords support equal angles at the circumference. Okay, and that is our answer. Moving on to the next question. Question 8.2.2 says, determine ABC, the size of ABC in terms of x. Okay, so looking at the diagram, ABC is this angle over here, and we need to determine this in terms of x. So you can just look at the shapes that ABC is a part of. It's part of this triangle over here, and in order to find it, we have x. We will need C1. And if we find C1, then we will know what ABC is. Okay, but with C1, I'm actually going to avoid going with this just because it's not as easy to relate C1 with other angles here. Okay, it's at the circumference. It's supported by AB. We don't really see any other angle supported by AB or anything like that. So let's look at it like this. We have a cyclic chord here. Okay. And we can see that angle ABC, that it is opposite angle D1. So the opposite angles of the cyclic chord, they add up to 180 degrees. So if we find angle D1, we can find angle B. Okay, so with angle D1, it's part of this triangle ADC or ACD. And do you see that AD, okay, AOD, that is the diameter. So it means that it's supporting a 90-degree angle at that circumference. So we can start off there and we'll be able to find angle D1. So angle ACD is equal to 90 degrees because of angle in a semicircle. Okay, reason angle in a semicircle. And now that we know that, we can just find this angle, angle D1. So it means that to find angle D1, you'll say, because these are angles in a triangle, they add up to 180 degrees. So we'll say 180 degrees minus 90 degrees minus x. So angle D1 equals 180 minus 90 degrees minus x because of the sum of angles in a triangle. Okay, and so angle D1 is equal to 90 degrees minus x. And now that we have angle D1, we can find angle B. So this is 90 degrees minus x. Now you know that the angles, okay, the opposite angles in a cyclic quad, they add up to 180 degrees. So angle ABC, or angle B really, angle ABC is equal to 180 degrees minus this angle. So when you subtract, you're going to subtract by the 90 and this negative x. So when you say minus negative x, it becomes a plus x. So this is 90 degrees plus x, and that is the size of angle ABC. And the reason for this is because of opposite angles in a cyclic quad. Okay, so that is it for this question, and that is the size of angle ABC in terms of x. Moving on to the next question. Question 8.2.3 says, prove that AB is parallel to CO. To prove that AB is parallel to CO, we can just use fun angles. So to prove the lines are parallel, we can use fun angles because we know that the fun angles are equal on parallel lines. So let's look at what we can see here. We can try proving, okay, using alternate angles. So if we draw a Z, if we can show them that angle A1 is equal to angle C2, then these are parallel. We could also do this drawing an F, okay. So if we can show them that this angle, angle ABD, is equal to angle O1, then they are parallel. Okay, now in both cases, I can see how this is definitely possible. With this one, we can just show that angle O1, okay, because it's the angle at the center, it's going to be twice the size of the angle at the circumference because they're supported by that same chord CD. Okay, so there's an easy way to show that. Now, the other way that we could do this is using the Z. So we can actually see that these would also be equal. Angle A1 is actually going to be equal to angle C2. Because do you see that OA and OC, that those are radii? Okay, so a radius there and a radius there, meaning this is an isosceles triangle. And so the angles opposite those equal sides would be equal. Okay, so I'm just going to go with this one because it just seems simpler to work with. Okay, so let's go ahead and tell them that angle O1 is twice the size of angle A2, which is equal to x. Okay, and of course this is because of the angle at the center being twice the angle at the circumference. Okay, so that means that angle O1 is equal to 2x. And so since we have that this is equal to 2x, we can see that this angle ABD is also equal to 2x, and this is equal to 2x, so they are equal. So let's just say angle ABD is equal to 2x, so therefore they are equal. So we say angle O1 is equal to ABD, and this now means that line AB is indeed parallel to CO because we can see that corresponding angles on these lines, okay, are equal. Therefore, the lines are parallel. Okay, so there we go, and that is it for question 8. Question 9 says, in the diagram below, BOA is the diameter of the circle centered at O. BE is a tangent to the circle at B, and EA cuts the circle at D. F is the midpoint of AD. So that is something we need to put down. F is the midpoint of AD, meaning AF is equal to FD. And the first question says 9.1, prove given reasons that 9.1.1 OBEF is a cyclic quadrilateral. So OBEF is this quad over here, and we have to prove that this is a cyclic quad. Okay, so there are some theorems that we can use to prove that a shape is a cyclic quad. The first is this theorem, If we can prove that the exterior angle of a quad is equal to the opposite interior angle, then it makes this shape a cyclic quad. The second theorem is if we can show them that the opposite angles add up to 180 degrees, then this is a cyclic quad. And the third case is if we can show them that the angles in the same segment are equal, then this is also a cyclic quad. But from the way this shape looks, the highlighted section, you see that we don't have actual numbers. Okay, so adding angles up to 180 degrees will be a bit of a challenge, but we do have an exterior angle in the cyclic quad. We have two exterior angles, so we could focus on that. Okay, so we're going to go ahead and use the exterior angle of a cyclic quad. Okay, so looking at this, we could prove that this angle, and it's actually better to focus on this side because look at this. We can actually prove that this angle over here is equal to this angle over here. Here's the thing with these two angles. BE is a tangent. OB is a radius. We know that the radius and the tangent are perpendicular at their point of contact. And over here, we have a situation where we have a line drawn from the center of the circle to the midpoint of a chord. That line is going to be perpendicular to the chord using the converse of the first theorem you learn with circle theorems. And now do you see that the exterior angle of this chord would be equal to the opposite interior angle? So that's what we can focus on. So we can show them that this angle B1 plus B2 is equal to 90 degrees because we have the radius being perpendicular to the tangent at the point of contact. So angle B1 plus angle B2 give us 90 degrees, and this is because radius is perpendicular to the tangent. And then we also have 90 degrees over here. So tell them that angle F1 is equal to 90 degrees. And the reason is because we have a line from the center of the circle to the midpoint of the chord. And that line is perpendicular to the chord. Okay, so that's what we have. And now do you see that they are both 90 degrees? So we can show them that angle B1 plus angle B2, that angle jointly, that is equal to angle F1 because they're both equal to 90 degrees. So therefore, OBEF indeed is a cyclic quad. And it is specifically a cyclic quad because we have the exterior angle of this quad being equal to the opposite interior angle. You could also say this is the converse of the exterior angle of a cyclic quad's theorem. Okay, so you can either leave it like that, converse of the exterior angle of a cyclic quad, or the exterior angle of the quad is equal to the opposite interior angle. And that is our answer. Okay, we've proven that that shape is a cyclic quad. Moving on to the next question. Question 9.1.2 says we need to prove that triangle ADB is similar to triangle BDE. So ADB is this triangle over here, and triangle BDE is this triangle. Okay, so how do we prove they are similar? We know that we don't have any lengths here of the sides, so we're going to use their angles. And if we can prove that all the angles in their triangles are equal, okay, the corresponding angles are equal, then that will prove that these two triangles are similar. Okay, so what do we have? We can start with this angle over here. Now, here's the thing. You see, when they name it for you, it's already enough of a guide for you. So ADB, BDE, right? We know that it is triangle ADB and triangle BDE. So this is already given a guide for you to see which angles would be equal. So you're looking at angle A in the red triangle and angle B in the blue triangle. And then you're just looking at them and asking yourself, why would they be equal? So looking at those two, why is this equal to this? Remember how BE is a tangent? So the angle between a tangent and a chord, this chord BD, it's going to be equal to the angle supported by that chord, which is angle A. So that's the reason those two would be equal. So let's tell them that angle B2 is actually equal to angle A. We can just call it angle A since there's no, confusion with that. It's not broken up into other angles. So angle B2 is equal to angle A. and that's because of the tan chord theorem. Okay, so we've got one angle down, two more to go. And then what other angles would be equal? Okay, now not even following that order, but I can see here these two angles. We can work with this because look at how this angle D1 is supported by a diameter. Okay, so angle D1 is equal to 90 degrees because it's supported by a diameter. So we can tell them that angle D1 is equal to 90 degrees, and it's because of the angle in a semicircle. Okay, and so therefore now we can find angle D2. So angle D2 lies on a straight line, so we just tell them angle D1 plus angle D2, that gives us 180 degrees. Therefore, to find angle D2, we'll say 180 degrees minus angle D1, which was 90 degrees. And so angle D2 is also equal to 90 degrees. And that's because of angles on a straight line add up to 180 degrees. So you see how those two angles are equal now. So we can say that angle D1 is equal to angle D2. There we go. We also have two other angles in those triangles. So that and then these two. So now by default, it means that the third angles are equal. Okay, so we don't even have to look for the third angle. We know now that the third angles are equal. Therefore, angle E is now equal to angle B1. Okay, that angle that we didn't use. Okay, and the reason there you can say it's because of that angle in a triangle or the sum of angles in a triangle. So angle E is therefore equal to angle B1. And I'll just go ahead and say this is because of the sum of angles in a triangle. So there, once we found two, the third ones would just automatically be equal. And so therefore, triangle ADB is indeed similar to triangle BDE. And we can go ahead and say the reason for this is because of angle, angle, angle. And that is our answer. Moving on to the next question. Question 9.1.3 says we need to prove that OB is a tangent to the circle passing through BD and E. Let's draw this first. Just also make sure to keep the things that we already found are equal. See, angle A is equal to angle B2. And we found out lastly that these two angles are equal. So angle E, that is equal to angle B1. We'll also just keep that in mind. Okay, so we have to show them that OB is a tangent to the circle passing through BD and E. So this is OB over here. This is a tangent passing through the circle B, D, and E. So let's just draw a small sketch of a circle there that has those points on the circumference. Okay, so something like that. So to prove that that's a tangent, I'm just going to make that smaller just so that it doesn't distract us in any way. We have this, and to prove that OB is a tangent to this circle, here's how we can do that. We can use a theorem about tangents. Notice that this little circle that we've just drawn here, we don't have any center, nothing like that. So we can't really use the angle from the center, okay, to the circumference is a radius. And so the radius is perpendicular to the tangent at the point of contact. We can't use that theorem. But we can use the tan chord theorem. So if we can show them that in this little circle, that this angle between this supposed tangent BO and this chord BD, this angle B1, if we can show them that it is equal to, and there we go, it's equal to this angle at the circumference of this small circle supported by this same chord BD, then that is a tangent that we have to the small circle. And already saying it, you see how we've already proven this in the previous question. We were able to prove that angle B1 was equal to angle F. That's why it's very important to make sure that you bring highlighters and, color pens into the exam room, at least 3 colors or 2 colors really, red and blue, so that you can just point these things out and you don't forget them. Okay, so let's just tell them angle B1 is already equal to angle E, which we've already proven in the previous question clearly. So tell them angle B1 is equal to angle E. And you can say proven, and you can actually just show them, hey, we've proven this in the previous question. So I'm just going to say this is proven. And I'm specifically just saying because we were able to show that the sum of the angles in a triangle add up to 180 degrees, or we could also say because they were the third angle in each triangle, okay, in the previous question. So because of that, we're finally concluding OB is indeed a tangent to the circle passing through BD and E. And the reason for this is not the tan-chord theorem. You use the tan-chord theorem when they tell you this is already a tangent, okay? But this time we were proving it's a tangent, so it's because of the converse of the tan-chord theorem. Okay, and that is our answer. Okay, and that is it for question 9.1.3. And moving on to the next question. Question 9.2 says, prove that OF squared is equal to AD times DE over 4. So let's go ahead and just find out where these sides are so we can see which triangles they're using. Okay, so looking at this, OF is this side over here, OF. Okay, and we'll say OF squared. And then AD is this side, and then DE is this side. So do you see how it looks like they're using sides of those two triangles we proved were similar, okay, previously. So we had these two triangles being similar, and they are using those sides. The only weird one that they're using is OF. So OF has something to do with one of these sides. Okay, if you look at this, you will start noticing that we have a situation here where OA is a radius, OB is also a radius, meaning these two are equal, and we're going to tell them this, okay? So we have the case of the midpoint theorem here. If the midpoint theorem is true here, it would also mean that these two sides are parallel, but it also means that DB would be twice the size of FO or OF. So that's probably where they're getting that from. So really, the sides they're using are AD in that bigger triangle, FD in the smaller triangle, and they're also using BD. But they replaced it with OF because of the relationship between those two lines using the midpoint theorem. Okay, so let's go ahead and start off with finding DB and really just the relationship between DB and OF. So we can go ahead and tell them that AO is equal to OB, or AO equals BO first. So if these two are equal, we can remove this for now. AO equals BO because we have equal radii. Now, since those two are equal, we now have the midpoint theorem here. We can also just tell them that AF was already equal to FD. We had proven that. So we'll say, I'll just go ahead and say, since we knew that AF was equal to FD, because this was already proven, then this would mean that the midpoint theorem is true here. So the conclusion I'm focusing on with this is DB and FO. So DB is twice the size of FO. So we'll say, therefore, DB is equal to 2FO, twice the size of FO. And this is because of the midpoint theorem. Okay, because of that midpoint theorem. So now instead of focusing on FO, because it doesn't really look like it's even in the picture, we can focus on DB. So the sides in these triangles they're clearly using are FD, DB, but you see that DB is part of both triangles, part of this triangle and this triangle. And then they're also using the side AD. Now we can go to the previous question and see where we concluded that these triangles were similar. And let's just include the sides they referred to. So if this is what we knew, we'll keep this here and let's just conclude from this. We know now that the sides that they have used, they use OF, but we know now that we're going to, in place of OF, we're going to use DB. Okay, so we're going to use DB there. And now you can see that the other sides they're using are AD. So when you're looking at AD here, it's the first and the second letter in the first triangle. So you have to take it as AD over the first and the second letter in the second triangle, which is BD. And this is equal to, and the other side that they used was DE. So that's the second and the third letter. Okay, that's this side DE. It's going to be paired with this second and third letter, this side DB. So we're saying that that is equal to DB over DE. You have to go in that order. If you started with this side being the numerator, then this side is also the numerator in the other fraction. And the reason we can use these proportions is because we had similar triangles. So we can tell them the reason is because we had similar triangles, and you can emphasize that these triangles were similar. So ADB was similar to triangle BDE. Okay, and now let's go ahead and see what we can get from this. Now you see that in their proof, they don't have DB, right? And that's because they clearly replaced it with FO, okay, but specifically 2FO. We've shown them that DB is equal to 2FO because of that midpoint theorem. So in place of DB, we'll replace that. So this is now AD over BD. I don't know why I wrote it as BD and in DB. Let's just leave it as BD. So this is BD, okay? So we'll replace that with 2FO is equal to, there's BD again, 2FO over DE. Okay, and now we have all the sides they're mentioning. We have AD, DE, and OF. Okay, let's call that OF as well, and here as well, OF. Now we can cross multiply. So this means that we're saying AD multiplied by, they kept it on the, they left it on the right-hand side. So let's just rewrite it there. It's AD multiplied by DE. And this is equal to 2 times 2 is 4. And then OF times OF is OF squared. And then you can see that they just clearly divided both hand sides by 4 to get that 4 on the denominator. So once we divide both hand sides by 4, then there we go. Indeed, OF squared is equal to AD multiplied by DE over 4. And that is our answer. And that is it for question 9. Question 10.1 says, in the diagram below, triangle ABC is drawn. D is a point on AB and E is a point on AC, such that DE is parallel to BC. Use the diagram to prove the theorem, which states that AD over DB is equal to AE over EC. Okay, so we're proving the proportionality theorem using this diagram. So to prove the proportionality theorem, we are using the areas of the triangles. And this is because with the areas of the triangles, we will be able to include these sides AD and DB. But we're going to treat AD as the base of this triangle ADE. And so with this base, we're going to find a perpendicular height. That height is going to go from the highest part of the triangle to the base. So if we're treating this as the base, then the height can be drawn from point E all the way to AD, and it needs to be perpendicular to AD. And we can go ahead and call this height H. Now we're going to do the same thing to this side AE. See how we have AE over there? But we're going to look at AE as if that is the base of this triangle again. And to draw a height, we would have to draw this height from this point D all the way to AE, and it is perpendicular to AE. And we can call that height K. Okay, great. Now we have AD and AE that will be included in this calculation. Now, how do we include DB and EC? We can do that by forming triangles that will have these as bases. So for DB to be the base of a triangle, this is how we can do this. DB can be the base of a triangle if we join B and E together. So if this is the triangle and we draw this triangle, you see that this triangle's base BD has been extended. And so the heights would also be drawn as from this highest point E all the way to the extension of that base. Okay, and it is perpendicular to this. So H is also the height of this triangle BDE. And then to include EC in this calculation, we're going to see EC as the base of a triangle, and we're going to draw this triangle by joining D and C together. So now that that has been joined, you see that in this triangle, this is an obtuse triangle, and we have K as the height of this triangle since it has been drawn by extending the base EC. Okay, so all we have to do is write down all the constructions that we have made. Okay, and then once you write your construction, then we can start proving this. Okay, so we're going to use the areas of these triangles because that will help to include these bases, these sides as bases. So here's how we're going to do this. We're going to find the area of this triangle, but looking at AD as the base of the triangle. So the area of triangle ADE, but we're going to put this over, and the reason it's going to be over this is because you see we have AD over DB. So we're going to put this over the area of the triangle with the base BD. So over that area. Okay, so that is this triangle BDE. So over the area of triangle BDE. And this is equal to, so the area of a triangle is equal to half multiplied by the base multiplied by the height. So in the triangle ADE, looking at AD as the base, that's the base, and the height is H. Okay, so multiply by AD multiplied by H. And this goes over the area of this triangle, which is a half, multiplied by its base, and we can see that that base is BD, and then multiplied by the height, which is also H. Okay, they have the same height. Okay, so we also say over H. And then you see with this that these would cancel. We have a half and half cancel, H and H cancels. And so it means that this simplifies to AD over BD. Great. So now we have the AD over BD part. That's done. But now let's get AE over EC. Okay, so we're going to use the areas of those triangles, but using AE as the base and EC as the other base as well. So this is the area, again, of that same triangle, ADE on top, over the area of this triangle with the base as EC, okay? That is this triangle, we can call this CED. And this is equal to a half multiplied by the base of, but this time we're making AE the base of that and then EC the base of this. So it's AE multiplied by the height, and the height of that was K over, and then it's a half multiplied by that base of EC, and the height is also K, as we can see. Okay, so that is the common height in both triangles. And because of this, these also simplify. So a half cancels with a half, K and K cancels, and this is now equal to AE over EC. Great. We also have AE over EC. But we cannot just automatically say they are equal. We're going to have to show them. So with the first one, with the triangle on top, the area of those triangles, you see how they are the exact same triangle, so we can't tell them that. But we know that the area of triangle ADE is equal to the area of triangle ADE. But now looking at these bottom triangles, because if you can show that these areas are also equal, it will show that their sides, their simplified sides would also be equal like that, or their simplified proportions. So look at these two triangles that we're looking at on the bottom. So this triangle over here and this triangle over here. Do you see that both triangles lie between the parallel lines DE and BC? So because they lie between parallel lines, it means that their height is exactly the same. If you go from the highest point of the triangle and down, really the height can be measured like this. You see how the highest points of the triangle are B and C? If you measured it, it's really just from the top there. And if you go perpendicular to DE, that will be the height. So we can see that their heights are exactly the same because they lie between parallel lines. But do you also notice that their bases are the same? If you look at it as if the base is DE, okay? If this is the base and this is the height, the base and height are exactly the same. They're sharing that base of DE. So that's what we're going to say. We're going to tell them that their bases and heights are exactly the same. So we're saying their areas are equal as well. So we'll tell them that we can see that the area of triangle BDE is equal to the area of triangle CED. Okay, and this is because they have the same base, and we can say that that base is DE, and they have the same height because they lie between parallel lines. Okay, and I'll just specify the lines that are parallel, that is DE and BC. So DE is parallel to BC. Okay, and so since their areas are the same, this would conclude that that area of triangle ADE, right, over the area of triangle BDE, that this is equal to the area of triangle ADE over the area of triangle CED. Okay, area of triangle CED. And so what they simplify to would also be equal. So remember how this simplified to AD over BD. So we'll say that AD over BD is therefore equal to, and that simplified to AE over EC. So AE over EC. And that is how we prove this theorem. Okay, so that is it for this question. Moving on to the next question. Question 10.2 says, in the diagram, triangle TPQ is drawn, and we have PQ and US are produced to meet at R. Okay, and then UR and QT intersect at S. SU is parallel to QV. Then they tell us that TU over UP. Now, I like to make sure that I just mark these so that we don't confuse the lines. So TU over UP is 2 over 5. So I'm going to see TU as I'm just going to call it 2K. And then UP, I'll call that 5K. Okay, so I'm just naming these because they're not the actual lengths of the lines, they're just their ratios. And then they tell us that 3QS is equal to 2ST. Now, that can be written like this, and we will do that. But the main goal is to find or calculate given reasons PQ over QR. So PQ over QR. So let's just find out what exactly this is. Simplify this. So 3QS is equal to 2ST. We can simplify this as a ratio by putting the side over the side. So it means that ST needs to go over to the left. And when it goes over, because it's multiplying by the 2 here, when we transpose it, it will now divide by whatever we had here. So it's going to divide by ST, okay? And when you transpose the 3, it's going to divide. So it's really just like seeing it as dividing both hand sides of the equation by ST to get rid of it. And then we want the number gone here. We only want these here, okay? So we'll divide both hand sides by 3. So therefore, QS over ST is simply equal to 2 over 3. And now we can also put down ratios for this as well. So this is QS, and we can call that, since it's 2 over 3, we can call this 2A. And this is ST, which we can call 3A. Okay, so now that we have this, to make this simple, okay, I'm just going to actually note down that we're going to be calling these sides these specific variables, okay? So 5K and 2K and so on. So after this, I'm just going to say let PU be equal to 5K and UT is 2K. So I'm just putting these down, okay? So PU is 5K and then UT, I'll call that 2K. So UT is 2K. Okay, just showing that it's from the same line. And then we also know that I'm calling SQ 2A. So SQ is 2A and ST is 3A. So ST equals 3A. Okay, let's see how we can find PQ over QR. So to find PQ over QR, you see that using the proportionality theorem, because we have parallel lines, we can use this triangle over here. So this is the line parallel to one side of the triangle. So to find this, you can see that PQ is in line with PV on the other line. Okay, so they're in proportion. And QR, that one is in line with VU. So in order to find PQ over QR, we need to be able to find an expression for PV and VU. So now we know what we need to find. And let's just put that down so we don't forget. This is what we need to focus on. We need to find an expression for PV and VU. Okay, so this is all we're going to look for now. So let's find PV and VU. VU seems much easier to find because we can find VU by using this triangle over here. So this triangle has a line drawn parallel to one side. So we're using the proportionality theorem. And we can say to find VU or UV, to find VU, we can say VU over UT is equal to QS over ST, which we already know. Okay, so let's go ahead and start with that. So that's the proportionality theorem we're using over there. So VU over, and that's over UT. So over UT is equal to, and we're saying that's equal to QS over ST. So QS over ST. And the reason for this is because we have a line drawn parallel to one side of the triangle, or we could also say the proportionality theorem, and then you can just tell them the sides that are parallel. Okay, and so because of this, remember how these have expressions that represent them. So in place of them, I will substitute. So I'm trying to find VU. That one is empty. And UT, we know that this is equal to 2K. So I'll say this is 2K is equal to, and QS or SQ, okay, that's SQ, that is 2A. So that is 2A over ST, which is 3A. So you see how here, because you're using ratios from the same line, those would cancel. Okay, so even if you wrote it as 2 over 3, it will be perfectly fine. I just call them letters so that I can better keep track of them. Okay, so what would happen here is they cancel. And now you can make UV the subject or VU the subject. But you see that 2K is on the denominator. So it's going to be in terms of K, which is great. And that's what we want, so that if this is in terms of K, we can also try to find PV in terms of K. And so it would mean that those ratios are compatible. We can use them together and we'll be able to find PQ over QR. Okay, so we can just multiply both hand sides by 2K so that we can get that out of the denominator. So this would mean now that, I will just rewrite it here. This would mean that VU is equal to, and this is 2 over 3 multiplied by 2K. So that's going to become 4K over 3, or 4 over 3K. Great. Okay, we have VU in terms of K. It's in terms of something we're familiar with in that line. Okay, so since this is in terms of K, I'll just rewrite it here so we can follow it. So that was 4 over 3K. And so now all we have to find is PV. But you see how simple it is to find PV, and it will also be in terms of K, because PU makes up 5K and VU makes up 4 over 3K. You see that if you say PV plus VU, they will give you PU. Okay, so to find PV, simply just say PU minus VU. And that's the equation we'll use. PV equals PU minus VU. Okay, so this is equal to, and so PV is equal to PU. We already know that's 5K as drawn in the diagram, and this is 4 over 3K. So I'll call that 5K. Again, you don't have to call it K. I just do this to keep track of it in the diagram as well. Okay, so what is 5 minus 4 over 3? That is, we can rewrite 5 as 15 over 3 minus 4 over 3. And so this is 11 over 3. Okay, so PV, I'm saying that this simplifies to 11 over 3K. Okay, so that is PV. And now, because PV is also in terms of K, 11 over 3K, we can finally find PQ over QR using this triangle over here. So this is the side drawn parallel to one side of the triangle, and we'll say to find PQ over QR, we say PQ over QR is equal to PV over VU because of the proportionality theorem. Okay, because those two lines are parallel. So here we go. PQ over QR. See, because these are now in terms of the same variable. Okay, we can call that now, that's 11 over 3K. And then VU, we already found that to be 4 over 3K. So divided by 4 over 3K. So you see how the K's will just simplify, and that's the whole reason I just keep it in terms of K, so I can ensure that I am naming it according to that specific line that it's on. Okay, the ratio that it would get according to that line. So we have PQ over QR, and you just have to find out what 11 over 3 divided by 4 over 3 is. Okay, so 3 and 3 cancels, and your answer is 11 over 4. And that is our answer. PQ over QR is therefore equal to 11 over 4. And that is it for question 10, and that is it for this paper. Okay, so that is the last question for this paper, and that is it for this paper. I hope you guys enjoyed it. Please make sure to like, share, and comment on anything that, you have questions on. And I will see you guys in the future videos.